Hello, so today we are going to do a walkthrough through Next.js's official tutorial. I thought it would be a good idea to do this because I did this tutorial recently and I did learn a lot of good things and best practices about working with a Next.js application. So I just thought it'd be fun to walk through it. So let's just go ahead and do that. It's a semi-lengthy tutorial, so I might have to do this in a couple of parts. But let's get started. I'm at nextjs.org. I'm going to click Learn Next.js. Okay, start learning. For this tutorial, I'm just going to kind of go through the instructions as they are. I'm not going to do too much explaining unless I'm kind of passionate about it because I don't want to keep this video that much longer than it needs to be. Okay, cool. So we're going to be building this dashboard application. And then so what's it going to have? It's going to have multiple pages. It's going to have authentication. It's going to have the ability to add, edit, and delete invoices, aka full CRUD functionality. Okay, some other cool features: styling, optimization, routing, data fetching, search and pagination, mutating data, error handling, form validation and accessibility, and authentication and metadata. So accessibility and metadata. You don't see that often in tutorials, so I think that's pretty cool. So let's jump down. Also optimizations, for sure. Prerequisite knowledge, basic understanding of React and JavaScript. They also have a React Foundations course, which I might check out in the future, actually. System requirements, Node 18.17 or later. So if you don't know what version of Node you have, you can just type in Node-V in your terminal. I have version 20.12 as of recording this. And operating system, just anything modern, Mac, Windows, or Linux. You'll also need a GitHub account and a Vercel account. So if you have a GitHub account, you can use that to sign up for Vercel. So if you have a GitHub account, you should be good. Let's get started, chapter 1. Okay, so they want us to start off with this repo, this example repo. And the reason why they want us to start off with a repository is one, to make the tutorial a little bit easier. It's going to have stuff for us already. It's not going to be from scratch, which I'm 50-50 on. I like starting from scratch, but their reasoning is because they want to reflect a real-world environment where you start with existing code bases. So that's their reasoning. All right, so I'm going to go ahead and just paste that command. npx create next app at latest. It's going to be called Next.js dashboard. We're going to use npm and take the example repo here. Enter. Okay, it's going to install. Should take about a minute or less. Okay, and we're done. So now we're going to cd into the dashboard, Next.js dashboard. And then we're going to go ahead and I'm going to open up my VS Code. And I'm going to split screen this. And we can give VS Code a little bit more room. Okay, I'm going to close my terminal. And they want us to look at the folder structure. So we have an app folder. And inside of the app folder, we have a lib folder and a UI folder. And then we also have a public folder, a scripts folder, and a next.config.js. We have a bunch of other files and folders too, but these are the ones they want us to highlight. So the app folder contains the routes, components, and logic of your application. This is where we'll be mostly working. The lib folder will contain functions such as rebuild, reusable utility functions, and data fetching functions. UI contains our UI elements like cards, tables, forms, and they've pre-styled these components for us. So we're not going to be doing too much CSS in this tutorial. Public contains static assets such as images. Let's take a look here. We have a bunch of images here. And scripts contain a single seed script, which we will use to seed a database later. We will be working with a real database. It's going to be Postgres. So that's pretty cool, especially if you only work with MongoDB. I like config files. So we have a bunch of them, but the one specific to Next is the Next.config.js. And yeah, right now we have no configuration options, but this is where you would put them if you had any, which we will use later, I believe. Okay, and I don't want to go a deep dive into the folders. I'll do it as they come up. So for example, here, placeholder data. If we go to app lib placeholder data, we will see some placeholder data. Placeholder users, placeholder customers. Okay, so that's going to be good for setting up the front end before we, connect to a server. TypeScript. So this project will be in TypeScript for the most part. And we can see in app lib definitions, a bunch of types. So we will be working TypeScripts, but they gave us the types for us. So we just have to work with TypeScript. We don't have to really create types. So it won't be too bad. And let's see here. So they're saying here, if you are a TypeScript developer and you want better type safety, use Prisma, which is an ORM, because here we're manually creating the types, but Prisma will generate them for you. But I'm going to stick with out using Prisma for this tutorial. Run the development server. Let's open up our integrated terminal in VS Code. Let's type in npm install, although it should have installed everything already, but let's just go ahead and run it. And we can run npm run dev. I'm going to go ahead and open this up on the side here, localhost 3000. That's where our server is running. And here is our application. I'm going to bring it right in here. Okay. Right now it looks really ugly because there's no styling right now, but welcome to ACME. This is an example for the Next.js Learn course. Okay, let's take it out. And let me just fix something real quick. Cool, okay. And we've finished chapter 1. All right, let's move on to chapter 2, CSS Styling. So currently our home page doesn't have any styles. Let's take a look again. Here we go. No styles. So in this chapter, we will cover several topics: adding a global CSS file, learning 2 different ways of styling, Tailwind and CSS modules, and learning how to conditionally add class names with the CLSX utility package. Let's start with global styles. So if we look inside our app UI folder, we will see global.css. Which is, so to use our global.css and apply it to all the routes in our application, it's good to add it to our top level component. So in Next.js, this is the root layout. Add global styles to your application by navigating to app layout. So app layout, and import the global CSS file. So we're going to import @/app/UI/global.css. Quick note about this @ symbol. This is a path alias, and we can use it because of TypeScript. And basically, @ represents the root. So from the root, enter the app folder, enter the UI folder, and let me get global.css. And we go to tsconfig real quick. We can see that setup right here. Okay. I don't know why sync cannot find body. Okay. So now, our development server should look like this. Let's bring it back. Here is our styled application. But wait a second. You didn't add any CSS rules. Where did the styles come from? Let's take a look inside global.css. Okay. You'll notice some Tailwind directives. So these 3 lines at the top. Tailwind is a CSS framework that speeds up the development process by allowing you to quickly write utility classes directly in your TSX markup. So in Tailwind, you style elements by using class names, kind of like Bootstrap. For example, adding the class text blue 500 will turn the h1 text blue. Okay. Although CSS styles are shared globally, each class is singularly applied to each element. That means if you add or delete an element, you don't have to worry about maintaining separate style sheets, style collisions, or the size of your CSS bundle growing as your application scales. Okay? And then saying here that when you create a new Next.js app with the create next app CLI, then it'll ask you if you want to install Tailwind. So it'll set it up for you. Okay. Let's go to app.page.tsx, and we see a bunch of classes attached to all these elements. These classes are Tailwind utility classes, and aka each one of these classes is a CSS style. I'll just put like BG blue 500 means background blue 500, which is a pre-built color that Tailwind gives you. You can use custom colors too. We'll see that later, most likely. Okay, so don't worry if it's your first time using Tailwind. To save time, we've styled all the components you'll be using. Let's play with Tailwind. They want us to copy this code, paste it in. So I'm going to bring this back here. We're going to paste it in above this P tag. Okay, and I'm going to save it. Let's see what happens. Get a nice black triangle. Okay. And time to take a quiz. What shape do you see? We see a black triangle. Check answer. Yay. Okay. If you prefer writing traditional CSS, we can use CSS modules. Okay. So in our app UI, let's create a new file called home.module.css, and we'll paste in these styles. So the class shape has these styles. These styles should be the same as those Tailwind styles that made that black triangle. To use CSS modules, we have to import it as a JavaScript object, usually called styles. Okay, and let's go ahead and remove the Tailwind. Let's comment out the Tailwind one. Save. Let's bring back our dashboard, and to use the CSS modules, we'll create a div, and we will give it a class name of styles.shape, because shape is what we called it in our module file. Save, and we get our black triangle back, but this is coming from our CSS modules, not from Tailwind. So you can use, basically the point of this is to say, hey, you can use Tailwind or CSS modules. Two common ways. Time to take a quiz. What is one benefit of using CSS modules? It provides a way to make CSS classes locally scoped. So locally scoped is the keyword. I skipped over it, but it says it right here. CSS modules allow you to scope CSS to a component by automatically creating unique class names. And it regurgitates that here. Create unique class names for each component. Okay, before I continue, I'm just going to go ahead and remove the CSS module. Actually, we'll keep it here as an example, but I'll just keep everything alone. Yeah, let's leave it alone. Let's go back to the tutorial. Using the CLX library to toggle class names, okay? So basically, it's really cool if we have the option to switch styles based on a condition. So CLSX will help us with that. So let's go to our app UI invoices status. UI invoices status. And so here we have the CLSX package. And we're using it to conditionally apply these Tailwind classes. So if the status, which is passed as a prop, if the status is pending, then make my background gray. If my status is paid, then make my background green. So it's only going to apply one of these sets of styles. So by passing a prop, we can choose to have the background green or gray. So search for CLSX in your code editor. What components use it to conditionally apply class names? So in my code editor, I will search CSS. And where is it being used? It's being used in the button, but I don't see that here. Being used in latest invoices. I don't see that here. Breadcrumbs. Don't see that here. Pagination. That's going to be the first choice. And status. So status and pagination. And let's take a peek in pagination. We're using it here. We're using it twice. So if it's disabled and not disabled, we'll have two different classes. If the direction is left and right, we'll have two different classes. And in status, status is the one we just looked at. The background gray and green. Cool. Other styling options, SAS, which allows you to import CSS and SCSS files, and CSS and JS libraries such as StyleGX, styled components, and emotion. Take a look at the CSS documentation for more information. So they reference a lot of documentation inside this tutorial, which I can't really show you because you can't click on my screen. But if you're interested in any of these topics, each chapter kind of has like a read further information here. So just go to the chapter and look for those references at the bottom. We've completed chapter 2. Alrighty, let's begin chapter 3, but first a little tangent. If you're interested in my VS Code theme, by chance, I'm using Grovebox theme by Jaden Life. Grovebox theme. Cool. Alright. Back to it. Chapter 3, optimizing fonts and images. In the previous chapter, you learned how to style your Next.js app. Let's continue working on your homepage by adding a custom font and hero image. So we will learn to make custom fonts, add images, and optimize the fonts and images. So why optimize fonts? The main point is this idea of cumulative layout shift. It's a metric used by Google to evaluate the performance and user experience of a website. So when you have images and fonts, if they don't load initially, the content might shift, as you can see here. So the layout shift and the initial load and the layout shift. You see the differences between them. So Next.js, they optimize this by, at build time, knowing how much space your images and your fonts take up. So that way there's no layout shift when you start up the website. So how does Next.js optimize fonts? It causes additional network requests. That's not optimizing. It disables all custom fonts. That's not optimizing. It preloads all fonts at runtime. So it's probably this. It hosts font files with other static assets, so there are no additional network requests. I'm gonna go with C? Oh no, I'm a failure. I should have read. Alright, we deserve to read this. Next.js automatically optimizes fonts in the application when you use the Next font module. It downloads font files at build time and hosts them with your other static assets. Okay. It hosts font files with other static assets, so there are no additional network requests. Okay, so I knew there was no additional network requests, but I guess I misunderstood how. Cool. And let's just read it again because I have to punish myself. Next.js downloads font files at build time and hosts them with your other static assets. This means when a user visits your application, there are no additional network requests for fonts which would impact performance. Cool. Okay. Adding a primary font, let's add a custom Google font. So in your app UI folder, let's create a new file called fonts.ts. Okay, and we will import the inter font. Import inter from next font Google. And then we'll export const inter is equal to inter subsets Latin. Let me turn off GitHub Copilot real quick for this. Can we just turn it off? Disable. Okay. finally add the font to the body element in app layout. Let's go to app layout, and we can import enter from .ui fonts. I'm going to replace this dot with @/app, and we can attach this to our body as so. Class name is equal to open a string templates, enter dot class name, and we're also adding this Tailwind class called anti-aliased, which gives us font smoothing. Oh, if you don't have IntelliSense for Tailwind, you need to add the extension Tailwind CSS IntelliSense for Tailwind. Okay, cool. And so now our fonts should have changed. However, I didn't show the difference, so let me remove this. Save. Let me show you what the website looks like now. And let me just refresh. Okay. I'm going to add that back. Okay. And I'm going to save it right now. Let's see the font difference now. We're adding the inter font. There you go. Hopefully you saw the difference, but now the font's a little bit different. And we can see this by navigate to our browser, open DevTools, and select the body element. You should see enter and enter fallback. So let's open our DevTools. Let's inspect our body right here. We will see here font family, enter, and enter fallback. Get out of here. Okay. Practice, add a second font. You can also add fonts to specific elements of the application. Now it's your turn. In your font TS file, import a secondary font called Lusitana and pass it to your P element in app.page. In addition to specifying a subset like you did before, you'll also need to specify the font weight. Once you're ready, expand the code snippet below to see the solution. So feel free to pause the video here and try it yourself. But I'm going to go ahead and just continue. So we also want enter, and we want Lusitana. Okay. And we'll export const Lusitana is equal to Lusitana subsets Latin. Okay, but it's going to say here, argument of type subsets Latin is not assignable to parameter of type weight 400, 700, style normal. So we have to add a, as mentioned here, you'll also need to specify the font weight. So we'll also have to specify the weights of 400 and 700. Save and export it. So let's go back to our page.tsx and we'll import Lusitana from our UI fonts. I'm also going to replace the dot with @/app. And we're going to put this in our P tag. So right here. Lusitana.classname. And let's see the difference. Save. There you go. Font's changed. And let's see the solution. Okay. Let's go to fonts.ts. We imported Lusitana and we created an object like I did. They put weights first, but it's not a big difference. And then in the page TSX, they import Lusitana from our fonts file. And they add the class name at the beginning, or add it at the end. Not a big difference. Finally, the ACME logo component also uses Lusitana. It was commented out to prevent errors, but now we can uncomment it. So this right here, this ACME logo, which is being imported from app UI ACME logo. Let's go ahead and look at it real quick. App UI ACME logo. This might need to be checked like that. Okay. So ACME logo is a div that has an icon and a paragraph. So this is ACME, which is a div with an icon and a text of ACME, and it's using the Lusitana font. Let's go back here, and we will uncomment this. Before I save it, let's bring back the app. Okay, and let's save it, and we'll see it show up. There you go. Again, it has a icon and text. Great. So now you've added 2 custom fonts to your application. Let's add a hero image to the home page. Why optimize images? Next.js conserves static assets like images under the public folder, which we have. Right? We have some images in the public folder. Files inside public can be referenced in your application. With regular HTML, we would use the image as follows: source, hero, PNG, and alt tag. However, this means you have to manually ensure your image is responsive on different screen sizes, specify image sizes for different devices, prevent layout shift as the images load, and lazy load images that are outside the user's viewport. So, AKA, Next.js has their own image component that's different from the native HTML one. That'll kind of take care of all of this for you. So the image component. The image component is an extension of the HTML image tag. Okay, so all the things we talked about here, it comes with automatic image optimization. Okay, so let's add the desktop hero image. Let's use the image component. So if we go into public folder, we will see 2 different images: hero desktop and hero mobile. Right, so this is just the hero images that we want to show on desktop versus the one we want to show on mobile. So let's go to our page component. And we will import the image component from next image. Okay, and we're going to put it somewhere here. Add hero images here. So let's open up the image component, capital I, and let's go ahead and just make some room. And we're going to have source is equal to /hero desktop.png. We're going to have a width of 1000 and height 760. Class name is hidden MD block. So this is it'll explain this in a bit. And alt is equal to, I'm not going to write that out, so let's copy this, our alt tag. Okay, and hero desktop. Am I missing something? Before I paste it, let's go ahead and show the website. Okay, and here's our website, and now I'm going to save it, and this is our hero image. I'll remove this comment. Okay, so you're setting the width to 1000 and height to 760. It's good practice to set the width and height to avoid layout shift. So this width and height is what Next.js will use to optimize the layout shift. So it says, hey, this image takes up 1000 width, 760 height. So let's reserve that space on our website for the image. So if it's loading very slowly, that space is still saved, and we're not going to have content, shifting. Okay, so you'll also notice the class hidden to remove the images from DOM on mobile screens, and MD block to show the image on desktop screens. So Tailwind is a mobile first CSS. So the styles you put without any media queries are what's going to be shown on mobile. And if you want to change things as the screen gets bigger, you add these media queries. So MD is a media query, which means min width 768 pixels. So by default, this image is going to be hidden, but once it gets to a medium screen, it won't be hidden anymore. It'll be display block. Okay, so basically hide this image on small screens, but once it gets to a medium-sized screen, make it a block. And you can guess what we'll do for the mobile one, right? By default, make it a block, but once it goes to medium screens, so by default, make it a block. Once it goes to medium screens, make it hidden. Okay. Here, practice adding the mobile hero image. So I'm just going to go ahead and copy this. And so hero desktop is called hero mobile. And it tells us the width is 560. It's from the tutorial, 560. And the height is 620. and we're switching these, right? So on medium screens, it'll be hidden, but by default, it'll be block. We probably don't have the right block, but it keeps it consistent. Screenshots of the dashboard project showing mobile version. Save. Okay, let's reveal the code just to make sure we did it right. Good. And let's show it in action, right? So what did I say? On small screens, we will see this image. And once it hits medium, this image will turn hidden and the other one will become block. There you go. So I guess this right here is the medium screen breakpoint. I feel like it could be fixed, but it's better than it's nice display of responsive styles with Tailwind using two different images. Cool. And create our homepage has a custom font and hero images. Quiz time. Images without dimensions and web fonts are common causes of layout shift. Yes, that's the whole point of this optimization. True. Images without dimensions and web fonts are common causes of layout shift due to the browser having to download additional resources. Some recommended readings, and we've completed chapter 3. All right, let's start chapter 4, creating layouts and pages. So this is a pretty Next.js-y chapter. So if you don't know anything about Next.js, this is kind of what makes Next.js Next.js, or a good chunk of it. So far, our application only has a home page. Correct. Let's learn how to create more routes and layouts and pages. In this topic, we will cover create the dashboard routes using the file system routing, understand the role of folders and files when creating a new route segment, create a nested layout that can be shared between multiple dashboard pages, understand what co-location, partial rendering, and the root layout are. So Next.js has an app router, which is a file-based routing system. So they're showing us here that if we have a folder called dashboard inside of app, and inside the dashboard folder we have a folder called invoices, this represents the URL acme.com/dashboard/invoices. And we can create separate UIs for each route using the layout.tsx file, special file name, and page.txt file, special file name. That's right. Page.txt is a special Next.js file that exports a React component, and it is required for the route to be accessible. In your application, you already have a page file, app.page.tsx. So this page.tsx right now lives in the app. So this is the home page associated with the route /. So these folders and the page.tsx associate to routes. So our page is going to be the home page. To create a nested route, we have to nest the folders and add a page.tsx file inside of them. So for example, inside the app, we'll create a folder called dashboard. Inside the dashboard, we'll create a file called page.tsx. It has to be called page.tsx. Okay, so this should be the app, the /dashboard page. And we have to export a React component. Save. So now if we go to /dashboard, we're at the dashboard page. Okay, and we can create different pages. Let's create a page in Next.js. So we create a new folder called about, and inside the about folder, we can put a page.tsx, and we'll create a about page. Okay, by having special name for pages, Next.js allows you to co-locate UI components, test files, and other related codes with your routes. Only the content inside the page file will be publicly accessible. So it has to be called page.tsx to become a page on your website. Inside our app folder, we also have this lib folder and UI folder. There's no page.tsx in any of these folders, so they're not going to render pages. Honestly, I would recommend taking the lib and UI folder and bringing them outside to the root, and only keeping your pages in the app folder. But that's just me. We'll continue with the tutorial. Okay. Practice creating the dashboard pages. So let's practice creating more routes. In your dashboard, create 2 more pages. The customers page at dashboard/customers, and the invoices page at dashboard/invoices. Okay. So if we want /dashboard/invoices, we'll have to create a new folder inside dashboard called, well, we'll do customers first. Customers. Inside the customers folder, we'll create a new file called page.tsx. Now the folder nesting gets a little bit confusing, but basically app just represents the slash. So /dashboard/customers. Okay, and so I'm going to copy this, and here to the dashboard page, we'll write customers page, save, and then in the dashboard folder, we'll have another folder called invoices, and in the invoices folder, we'll have another file called page.tsx. Let's copy this, and we'll have the invoices page, save. Okay, so if I did this correctly, if I go to dashboard/customers, I should have the customers page. For dashboard/invoices, I should have the invoices page. And if I go to dashboard/random, this should not exist. This should give me a 404 because I never created this folder. Right, see? Let's go back. Let's go back to our dashboard. Okay, get out of here. Reveal the solution. So the folder structure is dashboard, the page.tsx related to the dashboard, the customers folder, the page.tsx related to the customers folder, invoices folder, the page.tsx related to the invoices folder. So now we have 4 pages on our website. All we had to do was make folders, and inside those folders make a page.tsx. We did not have to install React Router. We did not have to set up a routing system. We just created folders and files, and that's what the app router in Next.js is all about. Okay, customer pages, invoice pages, we did this already. We need a dashboard layout. So dashboards have some sort of navigation that is shared across multiple pages. In Next.js, you can use a special layout.tsx file to create a UI that is shared between multiple pages. Let's create a layout for the dashboard pages. Inside the dashboard folder, so we're in the dashboard folder, create a layout.tsx and paste in the following code. Okay. So they're going to break some stuff down for us. So let's just go with second one. First, you're importing the sidebar component to your nav. Okay, right? We're importing sidebar into our nav. This is a component that they made for us. So let's take a quick peek into it. So we have a div. Inside the div, we have a link. The link just has the logo in it. It takes us to the home page. Okay, it's a link that has the logo in it. It takes us to the home page. Okay, then it has another div inside with nav links component. We can go to that in a second. We have a form. This form has a button which has an icon and a div that says sign out. So it's basically this form is the sign out button. Okay, and let's see it inside nav links. Inside nav links, we have an array of links for home, dashboard, invoices, and customers. And we're just mapping over them like React, and we're just creating a icon and a link for each one. So it's just a nav bar, okay? And it's called side nav because it's going to be on the side of the screen. We'll see in a second. And then the children. So any elements that we want to put through the layout. Let's go ahead and look. So in this case, this is our children right now, dashboard page. Let's take a look what we have, right? It's very nice, clean sidebar. Remember the links, home, invoices, customer. this link here, this is the home page, and a sign out button. This sidebar will exist on every single page that starts with /dashboard. I'll show that in a bit. And then the right side here will be the children. Okay. So they show us here. The benefit of using layouts in Next.js is that on navigation, only the page component updates, the layout won't re-render. Right, so that's really cool. So basically, when we change pages, only this part of the page will be loaded, and this part will stay the same. That's what they're trying to say. So we can see here that the layout is preserved on navigation. Right, this part right here. So let's go to our invoices. And we pretty much swap out the content of the pages here. So root layout. So remember chapter 3, we used the inter font on the root layout. And this layout takes in the children. So the dashboard layout lives inside of the root layout. So in this case, the children here is the dashboard layout. And the dashboard layout has its own children. So the layouts are nested based on our folder structure. Because dashboard lives in a folder that's nested inside of app. And the app's layout is the root layout. So that means the dashboard layout is nested inside the root layout. Okay, it probably says that here. So any UI element you add to the root layout will be shared across all pages in the application. You can also use the root layout to modify your HTML and body tags and add metadata. Since the new layout you just created is unique to the dashboard pages, you don't need to add any UI to the root layout above. Okay, and if you don't get that, I really feel like a picture might be nice to have. So a scale draw. So this is the root layout. Root layout, and basically it's just like everything lives inside the root layout. You have to have a root layout, and kind of we don't really have anything except that the inter.class name. So it's just gonna give us the inter class to the entire website. Okay, and then inside the root layout we have the dashboard layout. Dashboard. Okay, and then the dashboard layout is just going to give us a sidebar on anything inside the dashboard folder, and then our content would just be here. Cool, right? So, and we can have layouts even more nested if we wanted to. Okay, let's back up. So what is the purpose of the layout file in Next.js? Well, to share UI across multiple pages. And we've done with chapter 4. All right, let's continue this Next.js app router tutorial. So we last left off at localhost 3000, and I'm going to go to the dashboard page. Okay, and let's bring that back over there. And we're going to go to chapter 5 now, navigating between pages. So in the previous chapter, you created the dashboard layout in pages. Now let's add some links to allow users to navigate between the pages. So we're going to learn the next link component, the use path name hook, and just how navigation in general works in Next.js. So why optimize navigation? To link between pages, you traditionally use the anchor tag HTML element, and that's currently how we are set up, right? So let's go into the side navigation right here. And if we go into our nav links component, we see that we are using anchor tags for our links. And here's what they want us to notice. Pay attention to up here on the top of the browser as I switch through the links. Invoices, customers. You can see at the tab here that we are doing a full page load every time. And right, there's a full page refresh on each page navigation. So this brings up the link component. In Next.js, you can do the link component to do client-side navigation. Basically, we mimic the browser API to do client-sided routing. And so let's import in our nav links link from next link, and we're just going to replace the anchor tag. The props will all be the same. Okay, we'll save it here. And let's see here. As you can see here, the link component is similar to the A tag, right? Save your changes and see if it works. Okay, so let's just check out tabs. So pay attention to the tab up here again and the refresh. Let's see what happens. All right, we are changing pages, but there's no full page refresh. It looks very smooth and quick, and that's a really great user experience. But you still have access to the browser API. Like I can go to invoices and press back, and I'm still back at the dashboard. Okay, code splitting and prefetching. To improve navigation, Next.js automatically code splits your application by route segments. Okay, splitting code means that pages become isolated. If a certain page throws an error, the rest of the application will still work. In production, whenever a link component appears in the browser's viewport, aka when it's shown on the page, Next.js automatically prefetches the code for the linked route in the background. Right, so that's faster page changes. By the time the user clicks the link, the code for the destination page will already be loaded in the background, which makes the page transition near instant. And you can learn more. Quiz time. What does Next.js do when a link component appears in the browser's viewport? It prefetches the code for the linked route. Cool. Pattern, showing active links. So a common UI pattern is to show active links. So we see here that we are on the dashboard page, but how do we know? Besides looking at the URL. We're on the invoices page, but how do we know besides looking at the URL? So let's have a style here to indicate when we are on the active link, the current link we're on. And so we can use this hook called use path name. So let's import that. Import use path name. It's coming from next navigation. And because this is a hook, we have to turn this component into a client component, because it runs on the client, and we need access to the window, the browser window. So does it say anything more about that? Right. So every component by default in Next.js is a server component. So it runs on the server. So if we want to use stuff like hooks or DOM manipulation or functions or access to window, then we have to turn the component to a client component so that we can work with the client. So because we're using this hook, we have to use client. So whenever you're using a hook, use state, use effect, etc., you have to turn it to a use client. So we can use the hook down here in the function. Const path name is equal to use path name. And let me turn off Copilot again. Let's see here. Okay. And path name will return the path name. So it should return /dashboard/invoices if we're on this page. And now we're going to import CLSX. Right. Remember, this was the utility tool that we used to have dynamic class names. So we're going to change this into a template. No, we're gonna bring CLSX here, and we're going to wrap all these class names in CLSX. Okay, and then at the end here, we will open up a comma followed by a object, and in the object we'll have our dynamic class, which will be bg sky 100 text blue 600 if the pat name is equal to the link.href. So if the link is equal to the current pat name, then give these styles: background of sky blue and text of blue 600. Let's check it out. So we have the background of sky 100, text blue. We're on the home page. That's the active link. Customer, that's the active link. So good user experience here, and good showcase of the use pat name hook, which is really useful. Okay, completed chapter 5. Chapter 6, setting up your database. All right. So before we continue working on our dashboard, we need some data. In this chapter, we will be using a PostgreSQL database using the @Vercel Postgres package. Cool. So we're going to need a GitHub account. We're going to need a Vercel account, which again, you can sign up with your GitHub account to Vercel. And we're going to need to create a Postgres database. And then we're going to see the database. Create a GitHub repository. Okay, we can do this. So let's go to github.com. I'm not using my main GitHub here, just to keep it more clean. So we're going to go to the top right here. Look at this little plus. New repository. I'm going to call this YouTube Next.js dashboard. You can call it whatever you'd like. And that's pretty much it. And then press create repository. So this is our repository now. And okay, for now that's it. Create a Vercel account. So I believe I already have one. Let's see. Right, so I'll sign out real quick. Log out. So you can just log in with your GitHub to Vercel, vercel.com. Okay. There we go. And these are my 2 projects I have right now, but you can ignore those for now. And let's bring this back here. So connect and deploy your project. Next, you'll be taken to the screen where you can select and import the GitHub you just created. Do we need to push? Let's see here. Okay, so let's push this to GitHub first. So I'm going to stop the local host for a second. I'm going to clear my terminal. I will type in git status. Just go ahead and see what I'm going to be changing. Okay. Then I'll do git add dot, which will add everything to be committed. Clear. Then I'll do git commit flag m, so a message. Let's see here. Finished tutorial parts 1 through 5. Okay. And then we need to go to this repository we just made, and we can just copy everything here. Push an existing repository from the command line. Just copy this, paste in our terminal, press enter, and we have an issue. Okay, so I need to do something special. You will probably not have this issue, so I'm just going to change one thing here. Okay, I need to change this to GitHub. You probably will not have this issue. Remote origin already exists. Okay, so I have to remove git. Let's do some live debugging. Git how to remove remote origin. Git remote remove origin. Okay, let me try what I had before again. Okay, and could not read permission. Okay, I'm going to pause here and try to debug this real quick. All right, I'm hoping this will work now. Let's go ahead and press enter here. Okay, I have to remove. I have to remove the origin. what was the command again? Git remote remove origin. Okay, let's come back here, copy this, change this to test. Okay, we're good. And let's go back to our GitHub. Okay, it's right here. And then let me refresh the page. And now we have all our files in the repository. Sorry about that. You should not run into the issue that I had. It's because I'm working with multiple GitHub accounts. And so, Vercel, connect and deploy your project. Okay, so let's go to Vercel. So now that we make sure your GitHub files are all here. And then let's go to Vercel and click on Add New Project. And then we can import a GitHub repository. So mine are already loaded. I'm going to import the YouTube Next.js dashboard. Import. And before I continue, let's see if there's more instructions. Just hit deploy. Just hit deploy because it already knows it's a Next.js framework. Cool. So right now we're deploying the project. So Vercel makes it really easy to deploy, especially with Next.js projects. In like about a minute or so, you can just share this project with all your friends now at this point. So right now it's building. It's the same thing that would happen if you would be doing npm run build here. Compile structurally, it's linting, checking for TypeScript stuff. It's generating static pages, finalizing the optimization, collecting build traces. Okay, these are all our pages. Showing you which pages are rendered as static pages, which ones are dynamic. Looks like everything so far is a static page. Congratulations, you have deployed a project to Vercel. Get some confetti, and we can just click this, and we have our link. YouTube, Next.js. I'll make it a little bigger. Right, so this is a live link. You can go to this right as you're watching this video. You can go to this link right now, and go to this video. And the pages should work like /dashboard, right? Invoices, customers, okay? So this is the live thing. If we change anything locally, it's not going to change here, obviously. So let me go ahead and close this. Okay, so here's the cool thing now. Now when we're working in our project, every time we push to GitHub, it'll update it'll redeploy our application automatically. We don't have to redeploy ever again. Unless we have some kind of issue in the future. But if we're just doing like changing some components and pages, git commit, git push, Vercel's gonna trigger and it's gonna redeploy, and then boom, our website will be updated in a minute or two. Okay, so Vercel, not only can you deploy websites, you can also have instance to one free Postgres database on the free tier, which is what I have. So create a Postgres database. We're going to go to storage, and we're going to go to Postgres, serverless SQL, create. I'm going to accept this, and it's powered by Neon, which is a really great, check out Neon. You can also get a Postgres database there. They're doing really good stuff over there. With next door, create new Postgres, continue. So they're calling it Next.js dashboard Postgres. I am going to call it, let's see, I'm going to call it, I'm just going to call it YouTube Postgres, because I might want to reuse this database later, so I don't want to call it the dashboard. But you can call it whatever you want. Database name doesn't really matter. So Next.js dashboard Postgres, I'm going to call it YouTube Postgres. I think I'm going to change that to Destocot. That's my GitHub name here. So, yeah. And then US East, DC sounds good for me. Pick your closest location. Create. Okay, and then we can just go to connect. And what do they want from us now? Go to env.local tab, so right over here. These are all the environment variables we need. And we are going to copy them. Okay, so we have an env example. And are we going to rename it? Yes, let's rename env.example to .env. Okay, to .env. Okay, and we are going to copy all these environment variables. Okay, and we're going to replace these Postgres ones here. Don't replace the auth ones. We didn't get to that yet. So I'm going to paste that and try. I will delete this database once this tutorial is over. So I don't care if you see my variables right now. But do not show these variables to anybody. These are environment variables. They're meant to be kept secret. Okay. I'm going to close my env file. I'm going to go to .getignore. And I'm going to make sure I have it. See, make sure your .env is in your .getignore. Make sure when you type in get status, you do not see .env. That's .env.example. That's okay. We deleted it or renamed it. So make sure .env is added to your .getignore. And make sure it's not showing up in get status. We do not want to push the .env to GitHub. Okay. So now our Postgres setup. Let's bring up the. Let me clear my terminal. We can go back to. Okay. Now he wants to install this npm install add Vercel Postgres package. This is what we're going to use to connect to our database. Okay, that's installed. We can double check in our package JSON. So right here, Vercel Postgres. Let me close out all these components. Seed your database. So we're going to add a seed script. Let's see here, comma, and then seed, and we have node-r.env/config./scripts/seed.js. So config.env/config. So our node is like our Node.js. So they want us to run the seed file, which I believe is a JavaScript file, right? So we can run it, yeah. So seed.js lives in scripts folder, which it says here. And we're going to run it with the node, Node.js. And then we are registering .env/config, which should be installed. Yeah. And that just means we are registering our environment variables in that .env file. So if we don't have this, then it won't read the environment variables. So we cannot connect to the database. Okay. And now we can run npm run seed, which will run this script. Let's go ahead and real quick and look inside the seed script and see what's going on. So we're getting db from @Vercel Postgres, and then we're grabbing the placeholder data from invoices, customers, revenue, users. So let's go ahead and look at that real quick again. So in our lib placeholder data. So just, yeah, users is an array of users, customers an array of customers, invoices an array of invoices where each customer ID is associated with a customer's ID. And so each customer has a invoice. Revenue is just an array of months in revenue, and then we're exporting all 4 of these arrays. Okay, so we're bringing these arrays into seed. And we're also bringing bcrypt. So bcrypt is a library that will hash our passwords. Okay, so we are doing the, let's go to the bottom real quick. There's a lot going on here. I'm going to see if I can just say it quickly. Okay, so this is the main function. We are connecting to our database. And then we are running 4 functions: seed user, seed customer, seed invoices, seed revenue. We're passing in the client, our database client. And once we're done, we will end the connection. And this is how we start it. Main, we're invoking the function, and then we're doing a .catch. Just in case something happens, we will log an error has occurred while trying to attempt the database. So we only need to look at one of these because they're all pretty much the same. So let's go look at users. Seed users, and where we got here? Seed. I think it's important to like know what's going on. So Async function seed users. It has to be async because we're doing reaching out to our database. So we're doing raw SQL queries here. So await client.sql create extension if not exists UUID. So saying, hey, if we don't have the UUID extension, let's create it. So UUID extension basically lets us use UUIDs, and UUIDs are basically unique identifiers. UUID generator. So we're gonna have our IDs all look like this instead of like 1, 2, 3, 4. So these are more randomized, more less guessable IDs. Okay, so here's a let me see here. This is a SQL create table. So create table if it does not exist called users as ID UUID, a name as text, email text, password text, and then the email has to be unique. So we can't have users can't have this, different users can't have the same email. Okay, and then we'll say a little log here. We created the users table, and then inserted data into the users table. So we're using promise.all where we're mapping each user, which if you remember, there's only one user in our placeholder data. We will hash the password, and then we will return this SQL query. Insert into users ID, name, email, password, where the values is user.id, user.name, users.email, and then instead of the password, we're passing in the hashed password, which is the hash of the password. And on conflict ID do nothing. So this means that if this ID exists already in our database, don't do anything. Don't do any inserting. So once we inserted users, then we just log seeded insert users.length users, and then we return create table users.insert table. So we're returning this, but we're not doing anything with this in case we want to use this later. And then we're doing catch errors. So yeah. Let's go ahead and just run the script. So we're gonna seed users, customers, revenue, and invoices. So we can run npm run seed. Now let's show the logs. Okay, hopefully everything goes well. So yeah, so create a user table, seeded 1 user, created customers table, seeded 10 customers, created invoices table, seeded 15 invoices, created revenue, seeded 12 revenue. Okay, so our table is seeded. And quiz time. What is seeding in the context of databases? Deleting all the data? Nope. Importing the schema? Nope. Populating the database with initial set of data. Okay, that's what we want. Okay, so exploring our database. So we can go back to first cell, and we can go to all databases here. And we can go to, let me just refresh the page, maybe it'll show up. Right, so here we go. Here's my database. Click it. And I can go to, scroll down to data. And now if I see this drop down bar, choose a table, I should be able to see my tables here. So let's check it out. So in my users, I have my user. This is the hashed password. And then what else? We should have customers, a bunch of customers. And it's the UUID I was talking about before. Let's also see we have invoices. And we should have revenue. Cool. Okay, so our database was successfully seeded, and we can validate that by looking into our thing. Let's also run a SQL query just to verify. You can say select star. So give me everything from customers. Semicolon. Query ran successfully, and now here we have everything from customers. Okay, pretty much what we saw before, but we can test it out with a query, right? It's nice. Go back here. Executing queries, you can switch to query tab. Oh, okay, so this to interact with your database. This section supports standard SQL commands. For instance, putting drop table customers with delete customers table. So be careful, don't do this. Let's run our first database query. Paste the following queries. Okay, so we should have just done this in the first place. So we are selecting the amount column from the invoices table and the name column from the customers table from invoices, and we're joining the table customers on invoices.customer ID equals to customer ID, where invoices.amount is 666. It's a little confusing. Let me see real quick. Join customers on. Okay, yeah. So we're combining the invoices and customers table on the customer ID column, and then from that join table, we will select the invoices.amount and the customers.name from invoices, and only where the invoices.amount is 666. So it should have one item, I believe. Right, yeah, there you go. Amount name. We're selecting the amount from invoices.amount and name from customers.name. And so let's see here. It's amount 666 from name Evil Rabbit. What customer does the invoice bring? Evil Rabbit. Okay, that was a bit long. Sorry, I might have ranted a bit for a bit. So I'm going to stop here, and we're going to move on to part 7 soon. Part 6 is complete. All right, part 7, fetching data. Okay, now that we've created and seeded our database, let's see how we can fetch the data from our database. Okay. Let's just go up. Choosing how to fetch data. An API layer, database queries. Okay, let's see here. APIs are an intermediary layer between your application code and database. There are a few cases where you might use an API. If you're using a third-party service, or if you're fetching data from the client, you may want to have an API layer. Okay. In Next.js, you can create API endpoints using route handlers. Okay, so route handlers are very similar. If you ever used Node or Express, it's pretty much like that, where you make like in the back end, you make get and post routes, and you can access it from your client components in Next.js. Database queries. When you're creating a full stack application, you'll also need to write logic to interact with your database. So you can do that with SQL, like we're going to do in this tutorial, or with an ORM like Prisma. There are a few cases where you may want to write a database query. When creating your API endpoints, you need to write logic to interact with your database. If you are using React Server components, fetching data on the server, you can skip the API layer and query your database directly without risking exposure to your database secrets to the client. That's the cool thing about Next.js. You can fetch and reach out to your database within a server component. It's time to take a quiz. In which of these scenarios should you not query your database directly? When you're fetching data on the client, right? So when you're fetching data on the client, you want that API layer. Because if you fetch the database directly from the client, you are exposing potentially environment variables and secrets. You don't want to do that. Okay. We're going to use server components to fetch data because that's a big part of Next.js. So that's why they're emphasizing that. So server components support promises, so we can use async await, so we can do asynchronous tasks without using useEffect and useState, which you might have used in the past to fetch data. We can just directly fetch the data without storing it in state. It's time to take a quiz. What is one advantage of using React Server components? They automatically protect you from SQL injection. Not entirely true. They allow you to query the database directly from the server without an additional API layer. So that's what we want. Using SQL. For your Dashboard project, you write database queries using the Vercel, Postgres SDK, and SQL. There are a few reasons why we'll be using the SQL. So it's an industry standard, and basic understanding of SQL is important. It's versatile, and it protects the Vercel Postgres SDK specifically protects against SQL injections. And don't worry if you haven't used SQL before, they provided the queries for us. So we can go to app lib data. And look, we have queries for days. So like for example, write a simple one. Select star from revenue. Select everything from revenue. Okay. And at the top here, we're importing SQL from Vercel Postgres. Quiz time. What does SQL allow you to do in terms of fetching data? Fetching all your data in. Let's read this actually. This function allows you to query your database. Yeah, okay, that's what I thought. Fetch all your data. Fetch and manipulate specific data. Yeah, I assume it's this one. I hope I'm right. Okay, yeah. So SQL allows you to write targeted queries to fetch and manipulate specific data. If you use your own database provider, Right, so saying if you decide to use your own database provider from chapter 6 to the following along the tutorial, you have to update these queries to work for your provider. But we're sticking with the defaults. Okay, so we're going to fetch data for the dashboard overview page. So it's been a while, so let's go back to the dashboard overview page. We'll start up server again, actually. npm run dev. Okay. Here we go. Here's the dashboard page. Just a blank page as dashboard. And that's coming from where? That's coming from here. This page right here. Dashboard page. So fetching data for the dashboard overview page. So navigate to dashboard page and he wants to copy the following code. So let's do a quick inspection of what's going on here. Okay, we're just importing components, a card component, a revenue chart component, and a latest invoices component. We're gonna put a nice little H1, it says dashboard, and then we have a div that's commented out its children, but it's 4 cards basically. Okay, and it's in a grid. And then we have another div here, which is also a grid, and it's displaying the revenue chart and the latest invoices. Okay, so it's displaying data in cards and charts and in invoices. So if we just keep it simple, let's not dive into the components until we need to. So page is an async. We can make server components async. And because it's async, then we can do asynchronous tasks like fetching from the database. And that's what we're going to do. Okay, so we are going to import. Let me pull back up the data here. So all of our queries are in the single file, data.ts. So they want us to import fetch revenue from @/app/lib/data. Okay, and I spelled revenue wrong. Revenue. Okay, we can quickly look at this. So fetch revenue just fetches all the revenue. Select star from revenue. Give me everything from revenue. Okay, this is a function. So we can go ahead and await it because we're in an async component. Await fetch revenue. Okay, so now we have our data. And now we can uncomment the revenue chart component where we're passing in the revenue. Let's go ahead and save it. And we also have to go into a revenue chart component. So that's going to be in UI dashboard revenue chart. And everything here we need to uncomment. So let me see here. Yeah, so it's uncomment this. We can uncomment all of this. We can uncomment this, and that should be about it. So let's save here, and let's bring in our dashboard, and we have this chart coming. The details of the chart I will let you explore on your own, but the data, these values are coming from our database. And we can prove that real quick. So January is about 2K. So if we go back to our database, we go to browse revenue. See, January is about 2,000. Okay, so now let's fetch the latest invoices. So for latest invoices, we're just limiting it by 5. So we're just seeing the 5 latest invoices. And so we can import that function too. The fetch latest invoices. And then we can fetch that too. Const latest invoices is equal to fetch latest invoices. And don't forget to await it. Okay. And similarly, we can uncomment the latest invoices now. And then we can uncomment the stuff inside the latest invoices. So we'll uncomment this. Oh, we don't need this actually. And then uncomment all this. Okay, and then let's bring it back. Here we go. Now we have the latest invoices. Remember, we only queued the last 5. And we have the recent revenue. Also, we have to get rid of this comment right here. Recent revenue, right here. Cool. Okay. And they're nicely laid out because they were both living inside this grid container. Cool. So now practice on our own. Fetch data for the card component. Now it's your turn to fetch data for the card component. The cards will display the following data. Total amount of invoices collected. Okay, so you might be tempted to fetch all the invoices and customers and use JavaScript to manipulate the data. But with SQL, you can fetch only the data you need. It's a little longer than using array.length, but it means less data you need to be transferred. So let's try it ourselves and let's fetch the data for the card. Let me look at the data. Fetch card data. So we're returning an object. Okay, so we can just fetch all the card data. Fetch card data. And since we're returning multiple things here, we can just make an object. So wait, fetch card data, and then TypeScript will help us out here. Here we go, the number of customers, number of invoices, total paid invoices, and total pending invoices. And then this will allow us to uncomment all this. Okay, we have to do one at a time. Comment this card, and this card. So each card using a different set of data. Number of customers, number of invoices, total paid invoices, total pending invoices. And we have 4 different SQL queries. Select count from invoices, select count from customers. And I don't think we have to uncomment anything in cards, but we can look real quick. Title. Are we using this anywhere? I think it's okay for now. Seems to be okay. So let's look at what we have. We have 4 nice little cards here, and they're displayed in the grid because, again, they're living in a grid. And let's see what the solution is. So we import all 4 functions. We destructured them. We uncommented the cards. And that's pretty much it. Yeah, they don't want us to do anything with the card yet, looks like. So there are 2 things you need to be aware of. The data requests are unintentionally blocking each other, creating a request waterfall. So basically, we can't fetch the latest invoices until we fetch the revenue. And we can't fetch any of these until we fetch the latest invoices. So they're blocking each other. So by default, Next.js pre-renders routes to improve performance. This is called static rendering. So if your data changes, it won't be reflected in your dashboard. Let's discuss number 1 in this chapter and look at number 2 in this next chapter. Okay, so we're going to talk about the request waterfall, right? The blocking of each other. So the waterfall refers to a sequence of network requests that depend on the completion of a previous request. In the case of data fetching, each request can only begin once the previous one has returned data. Here's a little chart. So in parallel, it would be much shorter if we didn't have to do them one at a time. So yeah, so what I just said basically, we have to wait for fetch revenue before fetching latest invoices. The pattern's not bad, but there may be cases where you want waterfalls, but in this case, it's we don't want waterfalls because the fetching the invoices has nothing to do with fetching the revenue. So why can't we do them at the same time? When might you want a waterfall pattern? To satisfy a condition before making the next request? Right, so when we want the information from a previous request, then we should wait for it first. Parallel data fetching. So if we go to our data.ts, we see we're doing parallel data fetching here for our card component because we are using we're using promise.all, which lets us pass in an array of promises, and then we can execute them all at once, right? Right. So initiate all promises at the same time. Instead of doing await this, then await this, then await this, we're doing promise.all. Right. So we can use this pattern to fetch at the same time, which can lead to performance gains. One disadvantage of relying only on JavaScript pattern: what happens if one data request is lower than the others, right? So if we're doing it all together in parallel, if one of them is really slow, then we have to wait for that really, really slow promise to resolve to get everything back. So that's the downfall of doing the parallel request. That's the end of chapter 7. Looks like we don't want to change anything. Yeah. So on to the next part. Part 8: Static and Dynamic Rendering. So in the previous chapter, you fetched data for the dashboard overview page. Here's the data. However, we briefly discussed 2 limitations: the waterfall, so the blocking of the requests, and the fact that the dashboard is static, right? Which is not good, because dashboards are unique for each person. I shouldn't, if a new invoice comes in, I should be able to refresh the page and see the latest invoice, for example. But as of right now, I believe if a new invoice is added and you refresh the page, it will be the same. So, so what is static rendering? Static rendering, data fetching and rendering happens on the server at build time, so when you deploy, or during revalidation. The results can be distributed and cached in a CDN, Content Delivery Network. Okay, this is a chart here. So uncached is we are getting the data on each request. Where cached data, we are caching it between the to be reused each request. So whenever a user visits your application, your cache result is served. Okay, there's benefits of this: faster websites, reduced server load, and search engine optimization. So it's useful for UI that doesn't change often or doesn't have data, such as a static blog or a product page. It's time to take a quiz. Why might static rendering not be a good fit for a dashboard page? Because it makes the website slower? No. Because the server load will increase? No. Because the application will not reflect the latest data changes. So that's the important thing. Dashboard should be up to date. It's our dashboard. This is where all of we go for our information, but if our information is not updated, then that's not good. So what is dynamic rendering, right? It's the opposite. We get real-time data, user-specific content, and we get request time information. So it allows us to access information that can only be known at request time, such as cookies or URL search parameters. What kind of information can only be known at request time? The schema? No. URL path? No. Cookies and URL search parameters. Making the database dynamic. So by default, @cell Postgres does not set its own caching semantics. This allows the framework to set its own static and dynamic behavior. You can use the Next.js API called unstable no store inside your server components or data fetching functions to opt out of static rendering. So we're going to opt out of it manually using the unstable no store. So let's go to our data and let's import unstable no store as no store. So we're just renaming it to be more friendly as next cache from next cache. Okay, so we can use no store, and basically we just want to place this no store inside of every function. So it says, hey, don't cache this, don't make it static. I want this data to be dynamic. So fetch revenue. And looks like they want it in a couple of functions. Revenue, latest invoices, fetch card data, fetch filtered invoices, fetch invoices pages, and fetch filtered customers. Fetch filtered customers. I'm only doing the ones they tell us to here. and then fetch invoice by ID, which I think I just passed actually. So let's just click, how many do we have? We have 8. 1, 2, 3, 4, 5, 6, 7. 7. Why do we have 7? Oh, I think we have one that's just a comment. Yeah, okay. Okay, and so using unstable node store as an experimental API may change in the future. If you prefer to use a stable API in your own project, you can use the segment config option, export const dynamic equals force dynamic. Okay, so now we're going to simulate a slow fetch. So we're going to go to our fetch revenue function, and they gave us this. Console log fetching revenue data, await new promise, aka just delay it, wait 3 seconds before fetching the data. It's like a delay, artificial delay. And then log data fetching complete after 3 seconds. So we can go ahead and we'll see in the server down here. Fetching data revenue, data complete after. And then we can see this in action, right? I'm gonna refresh the page and it's gonna be a little slow because it's gonna wait the 3 seconds. So okay, and we are. See, it took a bit. Let's just test it out. Let's go to google.com, and then let's go to localhost 3000/dashboard. Now let's see how long it takes. See, it should have loaded by now, but the 3 seconds, see? And we get the log down here, data fetching complete after 3 seconds. Okay, so this is trying to indicate that, hey, this revenue one is slow. But why do we have to wait for revenue to show the invoices and the cards? We shouldn't have to. That's the problem. So with dynamic rendering, your application is only as fast as your slowest data fetch. So that's the end of chapter 8. All right, we still got some sunlight, so let's go to chapter 9, streaming. In the previous chapter, you made the dashboard page dynamic. However, we discussed how the slow data fetches can impact the performance of your application. Let's look at how you can improve the user experience when there are slow data requests. So what is streaming? Streaming is a data transfer technique that allows you to break down a route into smaller chunks and progressively stream them in from the server to the client as they become ready. Right, so it's kind of like our sidebar, how it's static on every single page on the dashboard. So just like this, we shouldn't have to wait for this to load if the based on some data about the revenue, for example. So we can separate our, in this diagram, we can separate our app into little chunks, right? And they can have their own. They can load in as they finish getting data. So by streaming, you can prevent slow data fetches that block the whole page. Okay, so the revenue here takes much longer to fetch data, but it's just as quick to render, load, and hydrate. So here's what we gotta do. There's 2 ways to implement streaming in Next.js. At the page level with the loading.txt file, there's a special file for Next.js, like the page.tsx and the layout.tsx. For specific components, we can use the React Suspense API. Let's see how this works. What is one advantage of streaming? Data requests become more secure, not implicitly. All chunks are rendered only after they are received in full. No, they're rendered in parallel, reducing the overall load time. Okay, streaming a whole page with loading.tsx. So inside the dashboard folder, you'll create a file called loading.tsx. And then we are gonna go ahead, you're gonna see an error right now because our component is blank, but we're gonna fix that in a second by exporting this component, loading, okay? So now, this loading.tsx is a special file that will show up whenever our page is still loading. So let's go ahead, remember those 3 seconds from the delay? I'm gonna refresh the page and we should see that loading fallback happen. See? Loading, once the 3 seconds are over, then we'll bring in the content. So suspending and streaming in the entire page. So loading a special file, right, built on top of suspense. Since sidebar is static, it'll show it immediately. And the user doesn't have to wait for the page to finish loading before navigating away, right? So we still have access to the sidebar, where before we didn't have access to anything. Okay, so we can add a loading skeleton. So instead of just having a little text here that says loading, it'd be nice if we had a skeleton, right? So let's go to our, so they're giving us a skeleton component. We can import directly, called dashboard skeleton. From, I'm gonna go ahead and do /at/app, save, and let's see what that looks like. Let's refresh the page. Remember the 3-second delay. There you go. So we have a nice skeleton of what the page looking, right? It kind of, you've probably seen this like on YouTube or something. And it's like, it's a very nice user experience. And if we go ahead into the dashboard skeleton for a second, we just see it's a bunch of tailwind. Background gray 100s. Just making the shapes. Feel free to export later. And we see a special class called Shimmer, which is just a bunch of these animations. All tailwind. And so, yeah, we see this thing. So fixing the loading skeleton bug with route groups. So right now your loading skeleton will apply to the invoices and customer pages as well. But we don't want a dashboard skeleton for the invoices, because the skeleton of the invoices shouldn't look like the skeleton of the dashboard. It's gonna have different content. So we can create route groups, another special Next.js thing. So with Next.js, we can create a folder with parentheses called overview. And we can go ahead and inside here, we can add the loading and the page files. And basically all this will do is, when we have a folder with parentheses, it doesn't count for our route. So our website is not going to be /dashboard/overview/ right? It's just still going to be dashboard. We ignore the parenthesis routes. But using the parenthesis routes can help us do two things. One, organize our folder structure. And two, it can help us put layout specific stuff. So this loading.tsx, see, because it's at the same folder level as customers and invoices, it's only going to apply to the dashboard, not the customer invoices. Where before we had this folder, the loading and the loading file was the customers invoices folder were nested inside the loading folder. The loading file was one level up than the customer's invoices, so it's going to apply to everything below it. But now it's on the same level, so we can only have the loading apply to dashboard. And we don't have to put the page here, but it's better for organization. So that's a little confusing. You can read more about the route groups later. They're really helpful for organizing your data, especially when you have a lot of files like this. And now we can stream in a component. So let's delete all instances of fetch revenue. So we're gonna go back to fetch revenue in the page. And we're gonna go ahead and delete this line. And we're gonna delete, are we deleting everything? That's the question I have. Oh, just the fetch revenue. Okay. And we're gonna import suspense from React. Import suspense. And we will import the revenue chart skeleton. And we can go ahead and, yes, surround the revenue chart here with the suspense. Fallback will be revenue chart. So this is very similar to the loading.tsx file. So this is React. So any React framework will have suspense. So we're wrapping revenue chart in suspense. And then so if the revenue chart is taking too long to load, as it loads, we will just show this fallback, the skeleton. And then once we get the data, then we'll get rid of the fallback and we'll show the actual component. And we're not going to pass the revenue into revenue chart anymore. we're actually gonna do it. We're gonna fetch the data directly in the component. So let's go to our revenue chart, and we're gonna import fetch revenue. This is already async. We can go ahead and remove all these props because now we're fetching it in the component. And then right here we can get const revenue is equal to await fetch revenue. So now we're going to fetch it inside the component, which again is wrapped in suspense. So remember, this 3 seconds delay is being fetched inside the revenue chart component. So while we're waiting for it to load, it's going to be suspended by the fallback. The skeleton's going to show. So we don't need this definition, it looks like. Yeah. And we can remove these comments. Just showing links to different ways to show charts. Okay, and let's go ahead and show you. So remember, the revenue data, I'm gonna refresh. The revenue data has that 3 second artificial delay. So, but we want to show everything that happens once we get the data. So if the revenue is still waiting for data, let's just let that component suspend. So let's refresh the page. Everything loads, but we're suspending the revenue component with the fallback skeleton, and then it just comes in when it's ready. So this is a really, really cool user experience, really cool way Next.js is making it easy for us to stream in components, right? So that covers all this, and we saw this already. So let's practice doing this with the latest components. So the latest invoices. So feel free to pause and try it on your own, but I'm going to go ahead and jump into it. Where are we? We're going to go to the page, and we're not going to fetch the latest invoices here anymore. I assume there's a latest invoices skeleton here. So latest invoice skeleton. We're not going to fetch this here anymore. So we're not going to need this. And then we will wrap our latest invoices in our suspense. Fallback will be the latest invoices skeleton. Okay, and then I'm going to assume we're not passing it in anymore. Okay, and then we're going to have an error because I have to change the latest invoices. Let's go into here, scroll to the top. We don't need any of these props anymore. We don't need this definition. We can import fetch latest invoices. We can go ahead and get that. So const latest invoices. Go to await latest invoices. No, fetch. There we go. And that should be good. So now we're back here. So everything should be the same here. Let's refresh. Right. So latest invoices comes in instantly, unlike revenue, because we don't have that artificial delay, and the data is pretty easy, fast to get. So let's put an artificial delay on the invoices too. Let's go to data. So fetch revenue has this 3 second delay. Copy. Let's make it 5 seconds. Let's make it 2 seconds. We'll make it 2 seconds. So right here. Let's do 2 seconds on the invoices. Okay, so let's check it out. When I refresh the page, the latest invoices should take about 2 seconds to load in, and the revenue should take about 3 seconds. So refresh. Nice. 2 seconds, 3 seconds, right? So each component will stream in once their data is ready. This is really cool stuff, and Next.js makes it, again, really easy to work with. Let's see the solution real quick. So fetch the card data. Oh, sorry, remove the things, remove everything, wrap the suspense with the latest invoice skeleton, fetch it inside the component itself, remove the props. Okay, there we go. Grouping components. Great, you're almost there. Now you need to wrap the card components in suspense. You can fetch data for each individual card, but this could lead to a popping effect as the cards load in. This can be visually jarring. So how do we tackle this? To create a more staggered effect, you can group the cards using a wrapper component. This means that the static nav will be shown first, followed by the cards, etc. So we are going to... Okay, looks like we're deleting the card components here. So yeah, we are not going to, like the other two components, we're not going to fetch the data here. We can go ahead and remove this. We're bringing the card skeleton. And then we are just going to, I'm going to copy this. We're suspending the, we're bringing in the card wrapper. So we're not using the card component. Okay, and we're suspending in the card skeleton. Let's go to the card wrapper. And in the card wrapper, we are, let's see here. We can import fetch card data. Import fetch card data. And then we are just doing what we did before, right? We're gonna destructure inside the card wrapper, and the card wrapper returns these 4 cards, just like we had before in dashboard. And the card wrapper lives inside the card file. The 2 components in the same file. So instead of suspending each card separately, we're suspending all 4 cards together, and we're having the skeleton apply for the whole thing at once. So it'll show 4 cards at once. So basically, if one of these happens to be slower than the others, we still have to wait, but it's still isolated from the revenue in the invoices. So deciding where you want to place your suspense boundaries. How you want the user to experience the page as it streams, what content you want to prioritize, if the components rely on data fetching. Take a look at your dashboard. Is there anything you would do differently? You could stream the whole page like we did with loading.tsx. You could stream every component individually. This may lead to UI popping. So they put a lot of effort into making these skeletons look really close to the actual component. But if you don't do that, you're going to have like that layout effect. The components will move around. Like imagine we didn't have these skeletons and then everything would just pop in like at full size. Everything would just move around, and that's not good to look at. So that's something you have to consider if you're going to do every component separately. You can also create staggered effect by streaming page sections, right? So like we did a wrapper component for all 4 cards instead of doing them separately. So it's just a lot of things to consider when doing the suspense. And don't be afraid to experiment, see what works best. And the main point is supposed to create a more delightful user experience, right? So you can start off just streaming the whole page, and then work your way to components as needed. Quiz time. In general, what is considered a good practice when working with suspense and data fetching? Move data fetches up to the parent component. No. Avoid using suspense for data fetching. No. Move data fetches down to components. So that's what we did. We took the fetches from the dashboard and we put them into their individual components. Cool. Okay, we finished chapter 9, but I just want to show off our work real quick. So let's go ahead to our data. We put a 2-second delay on the latest invoices. Let's put a 1-second delay on the card data. So it's going to take 1 second for the cards to load, 2 seconds for the invoices to load, and 3 seconds for the dashboard to load. I mean, for the revenue to load. So let's see all that in action. Each part will stream in as they're done. So 1 second, 2 seconds, 3 seconds. Right? Pretty cool, if you ask me. And we're done with part 9. Okay, let's start part 10. Real quick, I'm just going to go ahead and remove those artificial delays that we put in the previous section. So in the card data, we had a 1 second delay. I'm going to go ahead and remove that. And in the fetch latest invoices function, we had a 2-second delay. I'm going to delete that. I will leave the 3-second delay for revenue because that was in the tutorial itself. Let's close data, close latest invoices, close cards, close pages. You completed chapter 9. Let's go to chapter 10, partial pre-rendering. It's in the optional section, so we're just going to skim through it. So partial pre-rendering is an experimental feature introduced in Next.js 14, which is the current version as of recording this video. The content of the page may be updated as the feature progresses in stability. You may want to skip this chapter if you prefer to not use experimental features. This chapter is not required to complete the course. Okay. Let me see if there's anything I can really talk about here. Okay, let's just see. Combining static and dynamic in it. Currently, if you call a dynamic function inside your route, your entire route becomes dynamic. Okay, so if you're using like search params, the whole page will become dynamic. Okay, and this is how most web apps are built today. You can choose between static or dynamic for your entire application or for a specific route. However, most routes are not dynamic or are not actually fully static or dynamic, right? You may have a route that has both static and dynamic content, so why should it be all dynamic if it has both? So here's an e-commerce site by Next.js that has dynamic content here and static content here. It's a demo of partial prerendering, so you check it out, partialprerendering.com. You may be able to pre-render the majority of the products page, right? So the majority of this page should always be the same. Like it's not gonna ever like change. The nav bar, this information for this product, the product images, and basically everything with these pink dots. This is the dynamic data. Let's review. So everything with the pink dots is dynamic data, and everything not with the pink dots is static data. And that's what partial prerendering accomplishes. You can have static and dynamic data together instead of having to choose one for the entire page or application. So go back to our dashboard page. What components would you consider static and dynamic, right? So I would consider the sidebar static, and everything else I would consider dynamic, except for the titles. But like, the data is going to be dynamic. I want these to consistently update. If someone puts a new invoice in right now, I want it to be updated. So let's see. Let's see your solution, right? So dynamic, static, right? It doesn't. The sidebar does not rely on data, and it's not personalized for each user, so it can be static. The page data is personalized to the user, so it should be dynamic. So what is partial prerendering? Next.js 14 contains a preview of partial prerendering. It's an experimental feature that allows you to render a route with a static shell and keeping some parts dynamic, right? So something like the e-commerce site where the shell is static, but it has parts inside of it that are dynamic. And that way we don't have to have a fully dynamic page. When we know most of the site or some of the site is going to be static. And the shell lets us have a fast initial load, and then the dynamic parts will fill in as they are ready. Just like the streaming components from earlier. Okay? And then so yeah, this is a pretty experimental feature, so feel free to read more about it if you'd like. We're not incorporating this to our application. So what are the holes in the context of partial prerendering? Locations where JavaScript is disabled, locations where dynamic content will load asynchronously, locations where third-party scripts are loaded. So I think it's going to be, one second. And the shell leaves holes where dynamic content will load in asynchronously. So yeah, where the async components are. That's the holes in partial prerendering. How does it work? It leverages React's concurrent APIs, which I don't really know much about, and use suspense. Right, we just played with suspense last part to defer rendering parts of your application until some condition is met, aka the data is loaded. And then we have that fallback we talked about earlier. Let's see here. The static parts of the route are pre-rendered, and the rest is postponed until the user requests a route. It's worth noting that wrapping a component suspense doesn't make your component itself dynamic. Remember, you have to use unstable node store to achieve this behavior, but rather suspense is used as a boundary between the static and dynamic parts of your route. The great thing about partial prerendering is that you don't need to change your code to use it. As long as you're using suspense to wrap the dynamic parts of your route, Next.js will know which parts of your route are static and which are dynamic. Right, so just stick with the progressive enhancement and the suspense. So recap. Here's a recap of everything we did so far. We created a database. We fetched data on the server. We used SQL to fetch the data. We did parallelized data fetching with JavaScript. We implemented streaming, and we moved data fetching down to components. Cool. And that's the end of chapter 10. All right, so we last left off on part 10, and now we're jumping into part 11, adding search and pagination. go ahead and start chapter 11. And let's just do a quick look at what we had left off at. I am on localhost 3000/dashboard. So just hanging out over here. Let's pull this back over there. And let's go through this. Adding search and pagination. So in the previous chapter, you improved your dashboard's initial loading performance with streaming. Now let's move on to invoices page and let's learn how to add search and pagination. So just a quick recap on the loading performance streaming. I'm gonna go ahead and refresh the page and we should hopefully see the streaming in action. There we go, it's streaming in the content without affecting the other data. Really cool part, make sure you check out that streaming part a few videos ago. Okay, so in this chapter we will learn how to use the Next.js API's search params, use path name and use router, implement search and pagination using URL search params. All right, starting code. So let's go to our dashboard invoices page and app dashboard invoices page. It's empty right now. They want us to copy this in, so I'm just gonna go ahead and do that. Okay. Save. Why is here we go. So quick look at this page. We just have a div, and inside this div we have looks like 2 more divs. So this div just has a title of invoices, a search component with a placeholder of search invoices, and a create invoice, which I assume is a form. And then we have another div here with the pagination component commented out. And in here we have a suspense wrapped around a table, which I assume is a table of the invoices. But let's just check that out in our actual app. So I'm going to bring it back over here. Click on invoices. And here we go. We have this title and we have this search component with a button, which I assume all lives in. Let's check it out. Let's check out the search component. So it looks like it's just a search label, an input, and a magnifying glass. Okay. And then the create invoice looks like it's just it's a link. It's a link that goes to invoices/create. Okay, I see. So it's going to take us to a separate page to create our invoice. It's a little confusing because it looks like it's one form, but it's 2 separate things. This is a search for invoices, which will show up. This is a search for invoices, which will eventually show up here underneath. And this is a button that will take us to a different page to create an invoice. Anyways, let's go ahead and we familiarize ourselves with the page. Okay. And your search functionality will span the client and the server. So that's a really important aspect of Next.js. We can use client components and server components in tandem to accomplish dynamic things we want to do in our app. Why use URL search params? As mentioned above, you will be using URL search params to manage the search state. So we're going to keep state in the URL. And that's good because we can make bookmarkable and shareable URLs. We can do server-side rendering and initial loads, and we can do analytics and tracking. Okay, so add the search functionality. So we're going to work with the use search params hook, which will access the parameters in the URL. We're going to use the use path name hook, which will access the path name. So if we're on /dashboard, we'll get /invoices. We'll get the path/dashboard/invoices. Use router will let us navigate between our pages using the browser API. Here's a quick overview of the implementation steps. Capture the user's input. Update the URL with the search params. Keep the URL in sync with the input field, and then update the table to reflect the search query. All right, so let's do that. Let's go into our search component. And first things first, we'll create a search handler function. Function handle search term string, and then console.log term. Let me turn off GitHub Copilot. I'm recording on a different day. Cool. Okay, and then we're gonna hook up this handle search function to our input. So on change, we will take E, our event, and then we will pass it into our handle search. We'll pass in the value specifically. Okay. And now when we type, we should have the term show up. Let's go ahead and see that in action. Let's pull up the console. Let's make this window a little bit smaller. Okay. And clear this out. And let's type in hello world. Yep. So it's showing up here. We're getting our input. Okay. We tested that it works. So now, instead of just logging it, let's go ahead and update our search params. So we're going to use that hook. Const search params equals use search params, which comes in from Next navigation. And we're not going to log anymore. We're going to go ahead and create a params object using the new URL search params constructor, and we're going to pass in the search params. Okay, so these are our current params. So now we can add to them or delete to them. So if term, so if we have a term, let's go ahead and set query to term. So in our URL, we'll have something like this. Query is equal to, if term is hello, it would be like that. And then else params dot, so if we don't have a term, like if we backspace and the term is 0 characters long, or falsy, we'll just go ahead and delete the query search param. So now that you have the query string, you can use the router. So let's go ahead and pull in a couple things. Const pat name equals to use pat name. And then const, they are importing replace directly from use router, like this. Replace equals to use router. And remember, there's two use routers, one from Next router, one from Next navigation. When working with Next.js 13 and 14 and the app router, you want to use the use router from Next navigation. So everything is use path name, use routers, use search params, all coming from Next navigation. And they're destructuring the replace function directly, but I'm going to go ahead and just make one change because I think it makes it a little bit more readable. Instead of destructuring anything, I'm just going to call this whole object router. And then when we are going to go use this right here, instead of saying replace, I'm going to say router.replace. Okay? And then, because the router has several functions on it, router.back, forward, prefetch, push, replace, refresh. So I just think when going back to the nodes, it's easier to know like where is replace coming from. And then we're going to do a string temp literal, and we're going to go ahead and stick in the path name. So right now, the path name should be, slash dashboard slash invoices when we're on the slash dashboard invoices page. And then we're going to attach a question mark because that's what we need for query parameters. And then we're just going to go ahead and just stringify the params using the toString method. And yeah, so basically, as we search, we are creating the params and we're going to reset or delete them, and then we're going to replace the current URL with the parameters. So see that in action? So we're not logging anymore. Now we're going to keep it up here. So if I type in, for example, skateboard, you see it's coming in the query parameter. Skateboard thing is quite hard. And if I go ahead and delete, you'll see that it'll disappear. So now it's at 1 character, 0 characters, because we hit the conditional statement else. Okay. Now we want to keep it in sync. So here's the problem. If I type in skateboard and I refresh the page, the query parameter is still up here, but our search bar is empty. So let's keep that in sync. And the way we do that is we'll use the search params object again, and we'll just set the default value to search params dot get query. And It could be null, so .toString. Do we need the question mark here? Let's find out. We do. Okay. Otherwise, this will be undefined, and that's okay. It's just an empty string anyways. So now we can go ahead and refresh the page, and we will always have skateboard in our search bar. If I change this up here to, say, trench, enter, it'll sync with the search bar. So that's great. Okay. Default value versus value. So the default value, we can change it. It's not it's mutable. So if we change it to value, we will not be able to change it. Let's just test that in action real quick. So here I have trench. Let me try typing. And space. So we actually are able to type it. Did I not save? Oh, it's because we have the on change. We have the on change. So if I didn't have this on change, I refresh the page. Let me see. Interesting. Query. Right, so if we have a default value, or if we have a value, then we can't type in anything. But if I had this a default value, then I can go ahead and type into it. And we can type in in general because we have the onChange function. So the onChange will let us change it no matter if it's a default value or a value. But we want to use the default value to say, hey, we already had a query in the URL. Let's just set the default value. And this is what's called a uncontrolled component. Updating the table. Okay, so now we need to go back to the page. So we're done with the search bar. We accomplished the task of typing in the search bar and changing the query params in the URL. Go back to the page that the search bar lives in. And then Next.js has some special props that we can get. So let's go ahead and grab those props. And the props that it has is, or the one that we care about, is search params. And these are only accessible in the page components. And we want to TypeScript this out, so search params. It might not exist, but if it does exist, it's an object. And it'll have a query string and a page string. And this is based on this is based on our choice. Like we can have, I don't know, color string, right? It's just whatever we want to define in our search params. We were working with query and page. Let's go ahead and work with query and page. Okay, cool. And so now, before the return statement, let's go ahead and get the query using search params dot query. If that does not exist, make it an empty string. Const current page is equal to number. So we want to all search params are strings, so we want to make sure to parse it as a number. If we have one, otherwise we'll just make the current page one. And then let's uncomment this table. And we're passing in the query and we're passing in the current page to this table. Okay. Did I close the, no I did not. Okay. Okay, cool. So we have this table now, right? And let's go ahead and just quickly look at the table. So we're passing the query in the current page. And then we're using the fetch filtered invoices function to get the current invoices based on the query and based on the current page. We can look at that SQL statement real quick. So select invoices, ID, amount, date, status, select customers, name, email, image URL. From invoices, we're joining the table customers with invoices on the invoices customer ID equals customers ID. Where, and then here's where all the searching happens. I like means it's case insensitive. So hey, give me everything in the case where customers.name is like the query, or the email is like the query, or the amount in text form is like the query, or the date in text form is like the query, or the status is like the query. Order by the date, and then only give me items per page, which is a hard-coded value. Let's see here, items per page. Oh, here it's hard coded as 6, and then the offset is based on the current page. So from page 1, 1 minus 1 is 0, 0 times 6 is 0, it's offset of 0. From page 2, 2 minus 1 is 1, 1 times 6 is 6. So, you know, it makes sense. 6 on every page, so it's offset by 6 for on the second page. Okay, and we're just returning the rows. Let's go back. Okay, so we're going to get all the invoices, and we're just going to map them and display them. That's pretty much it. Map, display the picture, the name, the email, the status, the amount, the date, and then we have 2 buttons here for update and delete invoice. And these are table headers. These are table body. Why is it repeating twice? I am curious. Invoice. Oh, one is looks like it's it's a mobile. It's a mobile. This is the mobile. This is the yes, this is the mobile version, and this is the like desktop version. So these we're mapping twice. One's for the mobile. So I can show that real quick. Here's the desktop version, and it should change if I go to mobile. Yeah, see? It's a different layout. That's more suited for mobile. Cool. So that's why it's mapping twice, if anyone's confused about that. All right, let's back it up. It's a very long chapter. We're going to go ahead and we uncommented the table, and then we are jumping into the component. I already talked about it. Yes, so the question is when to use search params hook versus search params. Simply, if you're working in a page component that's not client, that you did not change to a client component using the use client directive. So if you're in a page component and you did not use client at top, then you can use search params. However, actually I'm curious about that. Can it be a use client and do we still have access to the search params? Let's find out real quick. Oh, but it can't be async, which is that an issue? Okay, let's find out. So yeah, we get an error here. Failed to fetch invoices. But that's happening in inside the actual table component. So let's comment out the table component. And let's console.log query and current page. And let's go ahead and manually add the query. Awesome, so you can still access the search params in the page component if it's a use client. So that's pretty interesting to know. Ideally, your page components should always be server components, and then anything client you should just do within a separate component. Like the table, for example, or the search bar. Yeah, the search bar is the perfect example. So this does not even have to be async, but I'm gonna leave it alone. And so like inside our search component, we have a use client. So try to keep the page component always server. Anyways, if you're on a page component, only then you can access the search params through the props. Otherwise, you have to use the use search params hook. And if you're using a hook, it has to be a client component. Okay, so the search component is where we use search params, and this was a client component. So that's how we accessed it outside the page. Okay, and then the table component, which has access to these search params, we pass them down through prop drilling. Okay, best practice, debouncing. Congratulations, you've implemented search, but we can optimize it. So inside your handle search function, let's add the following, console.log. Right, so we're going to go into our search, and we're going to learn about some debouncing. So what do they mean by debouncing? It means that we should not be calling the API every single time a user types into our search bar, because that's a lot of API calls. Debouncing is when we have a small little delay between each keystroke. So when I'm typing HELLOWORLD, like once it stops for like 2 seconds and there's no more changing, then it should do the search. So let's see that in action. So they just want us to show us that what's it look like without debouncing. We already know that. So as you can see, it's like, think about it. Every single time we're typing in here, this is an API call. And if you're typing a really long query, then that's a lot of API calls. Okay, so let's debounce, and we're gonna install a package. Looks like. Let me stop my server, and let's go ahead and install the use debounce library, npii use debounce. I is just shorthand for install, by the way. Let's boot up the dev server again. npm run dev. Everything should remain the same. Let's pull it back here. Yep, back to invoices. And we're going to import that hook. Again, this is a hook, but we're already in a use client component, so we can go ahead and just use it. Use debounce callback. And then we'll just wrap we're going to change our handle search function to a arrow function. Const handle search is equal to search term. Okay, and then we're going to wrap this function, this arrow function, in our use debounce. So use debounce callback, parenthesis, and we're going to need a 1 at the end, I believe. And that should be, yeah, that should be okay. And then we actually want to put a comma right here and add a second parameter called 300, which stands for 300 milliseconds. So there's going to be, if there's a 300 millisecond gap between the keystrokes, then it'll do the search. So let's make it let's just see that in action, hopefully. I'm gonna try to type really fast, so you'll see that we're not logging anymore. Hello world. World. See? It's gonna wait like the 300 milliseconds before searching. So now we're not calling the API. We're still calling the API pretty much instantly, but not on every single keystroke. Okay, and quiz time. What problem does debouncing solve? It speeds up the database? Nope. It makes the URL bookmarkable? Nope. It prevents a new database query on every keystroke, right? We don't want a query on every single keystroke. It's very bad for performance. We can go ahead and remove this console log while we're at it. Adding pagination. Okay, so now remember that offset in our invoices query. Let's go ahead and work with that. So we're going to go to our page component. Okay, and we had current page. We also need the total pages. So this is why we need the async. Const total pages equals to await fetch invoices pages by the query. Let's go ahead and look at this function real quick. So it takes in a query, and it's going to return a single number. Select count. So it's going to return a number. So it's going to do the same query search here. It's going to join the customers and invoices table, and then count. Just count how many rows we have from this query result. And then based on that, we're going to figure out how many pages we have. So we will get the count. We will turn the count to a number. So let's say it's 500 pages, or 500 invoices. Then we'll divide it by the pages, items per page. So there's 6 items per page. So let's say 600, right? So 600 divided by 6 is 100. So that means it's 100 pages. We'll also do mat.stealing, so we'll round up. We don't need to round up if it's 100 pages. And then we'll return the total pages. So the current page will be some number between 1 and 100, ideally. And the total pages will be 100 in my example. Okay? And then we can go ahead and uncomment the pagination component, where we will send in the total pages. Let's go into the pagination component. And looks like a lot of things are commented out. Let me go ahead and close down this terminal. And yeah, what do they want us to do here? They want us to import. They will use client, a directive at top. So we can use hooks. And the hooks we want to use is use pat name from Next Navigation and use search params. Okay, so we can go ahead and I guess we want to just do some stuff at the top. Let's remove this comment here. And I'm going to go ahead and copy some stuff here from the documentation. Copy. Paste. So we're going to get the path name from use path name, search params from use search params, and we're going to get current page from our search params. Although I don't know why we just don't pass it down. But we'll follow the documentation. Or the actual tutorial. So, and then we're going to create a function here. Const create page URL. So we'll take in the page number, and we will get the params, and we'll set the page to the new page number, and then we will return the path name. So this creates a new page URL for us to go to, I assume. And then let's see here. We want to do what? Okay, let's go back to. We want to go back to the search component. Can I find it here? Search, search, search. Where is the search component? Oh, right here. And then when we change a query, let's go ahead and just reset the page back to 1. Page 1. Which makes sense. If it's a new query, we should go back to the first page. And it has to be a string, because search params are strings. Okay, close this, and are we done? Oh, we just need to uncomment all this now. Okay, and comment this. So we have this, looks like a utility function called generate pagination. This will take the current page and the total page, and it'll go ahead and just generate how you want the pagination to look. So if it's less than 7 total pages, we're going to return an array from 1 to 7, or 1 to whatever the total pages are. If the current page is less than 3, we will go ahead and return 1, 2, 3. Interesting. Oh, so if we're here, that means there's more than 7 pages. So we're just going to return 1, 2, 3, dot, dot, dot. If we're on less than page 3. If we're on greater than page 3, then we're going to return, then we're going to check if it's less than, if we are, it's pretty confusing. If the current page is among the last 3 pages, show the first 2 and ellipses in the last 3 pages, right? So it's making it nice to show for the user depending on what page you're on and how many total pages they are. You can go through the logic yourself. But what it looks like on the page is basically this, right? 1, 2, 3, arrow, which means that we had less than 7 pages, so it's returning an array from 1 to 3, right? Because the index is at 0, so it's I plus 1, so it's 1, 2, and then 3. So 0, 1, 2. So we're in the first statement here. So if the total number of pages is 7 or less, display all pages without an ellipses. So we have no ellipses here, as we can see. Okay, and then let's just quickly check this out. So we have an arrow, a pagination arrow, left and right arrows, and then we have the pages that are mapped, and my question is, why are we not showing this? Is this a separate component? Let's see here. Oh, we do have it. It's just hard to see. If you can see really carefully, there's an arrow here, but it's disabled. That was tough to see. Pagination. So yeah, we have 2 arrows. Let me see if I can show them at the screen at the same time. Yeah. So we have 2 arrows. The left arrow here, it's disabled if the current page is less than or equal to 1, which makes sense because we're on page 1, so we can't go back. Then we have a right arrow, which will be disabled if the current page is greater than or equal to the total pages, right? It should never be greater than, but you can always type it manually in the URL. And then these arrows, I believe these are links. right? These are links. So because of that, when we click them, we'll be changing the URL to reflect the. So take a look at the URL. So if I click 2, it should go to, or click the arrow right, it should change to the next page. 3. And this is changing the search params. And if we're changing the search params, then we're changing the query. If we're changing the query, we're fetching new invoices. And we also have numbers here. So the arrows just go to the next and previous page. And then these numbers are coming from this div where we are mapping all pages. Remember, all pages was those arrays we got from the generate pagination function. And then we're just doing a position of first, last, single, middle. So this is a little bit of interesting logic here. So position first, all pages are linked. So this is some logic that we have just to make it look like this. Some really nice pagination. So we can just see here that we have, right, so if we are first, we're gonna give it a round. It's just styling. Okay, this is logic to help us style it nicely. We don't really need most of this, but that's how you get a really nice looking pagination component. I recommend you take a look at this component carefully and try to replicate it, because this is I assume Next.js did some best practices when it comes to making a pagination component, which has a pretty decent amount of difficulty and logic involved. Okay, this was very long part. So let's go ahead and end it right here. We've completed chapter 11. Let's just put it all into action real quick, actually. So I want to search for Stephen. So let's go to page 1 and let's type in Stephen. Let's go to page 2, 3. Let's go to page 3, and we'll see that it's going to reset to page 1 if I type in a new query. Okay, so we're back to page 1 and we type in Stephen, and that means our total pages is 1 because there's only 2 results, and we can't go back and write because these are disabled. And we can go ahead and clear out the query to get back all the invoices. Again, now pagination works. Search params works. Let's look for evil rabbit. There he is. And yeah, chapter 11 done. Sorry that took a little long. I might have rambled more than I needed to. Let's stop here. All right, so we're going to go ahead and start chapter 12 of the Next.js App Router official tutorial. And let's jump into it. So it's mutating data. Learn how to mutate data with server actions. Okay, so let's just jump into what are server actions. And let me highlight the first sentence. React server actions allow us to run asynchronous code directly to the server. In other words, to keep it simple, we can, really cool thing that Next.js really popularized is these server actions. And basically we can just call a function in our components or pages that runs on the server. And basically what this does, it just makes it a more JavaScripty way to work with the backend without creating a whole API route. So under the hood, this function is just making a post request for you. That's pretty much it. And we can do that through the HTML form element using the action attribute. We could also use it without the action attribute, but that's going to require probably making a client component. But since the action attribute of a form component natively sends a request, we can just pass it here. So, right, the idea is progressive enhancement. Forms work even if JavaScript is disabled on the client. You'll see a lot of tutorials use the term progressive enhancement. Basically, small things we can do to put more of our app onto the server. Less load for the user to have to pull on their client. So server actions are also deeply integrated with caching. So when a form is submitted through a server action, not only can you use the action to mutate data, but you can also revalidate the associated cache using APIs like revalidate path and revalidate tag. So more on that later. Benefit of server actions, progressive enhancement. Okay, So now we've been querying a lot of data. Let's go ahead and figure out how to add data. For example, how to create an invoice. So I'm going to pull up onto our dashboard again real quick. Here's our dashboard. And so we have to do the following. Create a new route and form. So inside our app folder, inside our dashboard, inside our invoices, we will create a new folder called create. And because we are using Next.js app directory, this is basically a new endpoint. /dashboard /invoices /create. And inside here, we will put a page.tsx file. Okay, and now let's just copy this component. And then let's do a quick glance. So we just have a main component. Inside we have a breadcrumbs component, which would just nicely show like what part of the app we're on. And then a form, which is a custom component, capital F, which will take in customers from await fetch customers. And again, await fetch customers just gives us the ID and name of all the customers. Okay, let's save this. Let's go to that page. So back here, so /invoices, and that should link to this create invoice button. Create, and here's the form. So up here, this is the breadcrumbs. Okay, these are clickable links, and this is the form. We can look at the form in a second. So again, each customer has a name and ID. We'll go here, and we just have a form component, which has the name, and then a select input for the name, and we can choose any of the names that we get. So here, all the names are mapped over as options of a select element. And same thing, and the amount is just the input field. We can choose whatever we want to put in here. And then we have a field set, which is acting as a wrapper for radio buttons. 2 radio inputs for paid or pending. Paid or pending. And right now this form should have, it has no on submit, no action, so this form's not gonna do anything right now. We can test that out. Type in ACME, $100, pending, create, submit. Just gonna refresh the page. Default form action. Okay, I went ahead and explained what the components are. We'll see the following UI. Let's create a server action. So they want us to go make it in a separate file. So in lib, we will create a new file called actions.ts, and we will stick a use server directive at the top. And in short, this marks the entire folder to allow server actions. So anything running here will be ran in the server. And by declaring at the top, that means everything in the file will be a server action, and we don't have to say use server for each function separately. So export async function create invoice. This takes in form data, which is a form data object. Okay, and now we can go back to our form, and let's just import that function. Import create invoice. Yeah. And then we'll pass it as an action here. Create invoice. Cool. So as long as each input has a name property or select, as long as they have a name property, we will pass the value of each of these form inputs to this form data object automatically. Okay, now let's go to here. Behind the scenes, server actions create a post API endpoint. This is why you don't need to create API endpoints manually when using server actions. Okay, now we will extract the data from the form data, which is what I just said. So const raw form data is equal to customer ID form data.get customer ID. Amount is form data.get amount. And let me just copy this down. This will be status. And let's go ahead and just log what's going on here. Raw form data. Okay, so let's try it out. If I select Evil Rabbit at $120 and he's pending, we'll create invoice. Go back here and we will see that we are logging the data. And remember, it's on the server, so it's not going to be in the client. If we go to our console in our browser, we see nothing. And it's logging here because I have my Console Ninja extension, but if you go to your actual terminal, you'll see that it's being logged right here. Okay, and it gives you some tips. If you have a lot of fields, you can use the object.fromEntries method. We only have 3 fields here, so we just did it one by one. Okay, so now let's validate our data. Let's see here. Type, validation, and coercion. Right, so it's saying that by default, anything we get from a form data is a string, but ideally we would want the amount to be a number. So we are going to use a library called Zod to validate and also coerce our values to fit how we want them before we insert them into our database. So we're going to import Z from Zod, and we will create a form schema. We will call z.object, basically means it's an object, and then we will just define our schema. Customer ID should be z.string. And Zod is an awesome library. I recommend checking it out in more detail. z.coerce.number. Status z.enum. Pending. Paid. Date is z.string. I spelled schema wrong. And let's see here. And then we want to take this base schema and make a create invoice schema, which is going to be form schema.omit ID true, date true. And we are going to omit these fields because these will be automatically created when we insert a new entry into our database. So now we can take our raw form data and we can pass it into create invoice.parse. And this will validate our schema and will allow us to get our data the way we want it. If our data is not good, this will throw an error. So we will not get these data. It will just throw an error. That's what parse does. It parses based on this schema. Okay. So we want to store the value in cents. Okay, that's fine. So next line we'll say const amount in cents is equal to amount.100. I think it's always better to store in cents because it just makes money easier to work with in general. And then convert it to how you say any format you want later. So we're also gonna create the date ourselves, looks like, instead of letting the database auto-generate it for us. To iso string dot split on the t and 0. So we're just formatting this date because we don't want the entire thing. We just want to split on the t and get the first part. Okay, so now it's time to insert. We can import SQL from for cell SQL. And we can do await. I love a raw query. Insert into invoices, customer ID, amount, status, date, values. I'm just gonna go ahead and copy this line. And I might be missing something. No, that's good. Okay, so now right now it says we're not handling any errors, so we'll get to that later. Next chapter. So revalidate and redirect. So we're gonna import revalidate pat, and we're gonna put it after our SQL statement. Again, we're not handling errors right now. They said we'll take care of it in the next chapter. So revalidate pat is basically if we have data on a pat. So let's go to invoices for a second. This is the data on our invoices path. And right now, if it's cached, it's never going to update even if we create a new invoice. So revalidate path will manually let us pass in a path. And once we call this function, it'll revalidate the data. So if there's new data, it'll show up. And of course we want this to happen after we insert a new one. And we're also going to import redirect from next navigation. And basically once we create our invoice, let's just go back to the dashboard invoices. Dash. Congrats, you've been implemented for server action. Okay, let's try it out. So it looks like we are ordered by the newest date. So we create a new invoice. Let's do it for Lee Robinson at $200 pending. Create invoice. There you go. Brand new server action. Look how quick that was. Now we're going to do updating an invoice, which is going to be very similar. We are going to utilize dynamic endpoints with the app directory. So we will go to our invoices folder again. We will create a new file, new folder called ID. Because now it's in brackets because it's dynamic, right? Which invoice are we associating to? We can't just say invoices/1, invoices/2. So ID will catch will cover everything. And we don't have to call it ID, we can call it whatever we want. For example, post or slug. And inside the ID, we will have a folder called edit. And inside edit, then we will have our page.tsx. So basically, using the app router, we are on /dashboard /invoices/ID/edit. And ID will be an ID of an invoice. So like 1 or 2 or 3. Okay, let's go ahead and copy this component for this page. Or are we missing something? I will leave this page blank for now. Let's go to app UI invoices table.tsx. App UI invoices table.tsx. And then we want to see that we have let's minimize this. And let me make this a little bigger. Yeah, we have an update invoice button, which is this pencil. And we want to change the href. So let's go inside update invoice. And here's the href. We don't want this. We want to make it dynamic. So it'll be invoice/ID/edit using string template literals. Save. So now if we go back here, if we look at the bottom left where the address will show up, we'll see here. This is invoices/that UUID, then this UUID/edit, this UUID/edit. Okay, and now we can go to our page.tsx TSX. Close this, close this. We'll copy this. Again, we have breadcrumbs and then we have a form. But right now we don't have ID, invoice, and customers. So let's get that. We are going to use, like earlier we used search params, but now we're going to use params. So params, quick difference here is that slash dashboard slash invoices slash ID slash edit. These are params right here. Whereas query params, search params or query params is going to be something like this. Query is equal to hello. These are search params and these are params. Here we want the params. It'll always have a param because we are on slash ID slash edit. So params is going to be TypeScript ID string. And then, sorry, I typed that wrong. It should be params like this. Okay, and then we can go ahead and distract that. Const ID is equal to params.id. Okay, that takes care of the ID. And we want to now fetch some functions. So import fetch invoices by ID. Fetch invoices by ID and fetch customers. Okay, and then we can do const invoices customers. We can use promise.all to do both queries at the same time. Fetch invoice by ID, ID, comma, fetch customers. Customers. Invoice. Look at these functions real quick. This will take an ID, and we will just find the ID based on the ID. And we will return it. We're going to change the amount to from cents to dollars, and we will return the single ID. Fetch customers, we saw that already, just returns all the customers. Okay, so now we can, it says we should have a TypeScript error, but I don't see it here, so let's ignore that. And now let's go to here. So if we click an edit button on any of these, it should properly give us the right thing. So let's look at Michael, I can't say it, so I'm gonna go, let's go Stephen Tay. He's at $448 paid, so let's press edit. Go Stephen Tay, $448 paid. Right. So let's go to our form, and it's a different form, edit invoice form, and we have default values for our based on our invoicing customers. Where's another default value? Default value. Here, default value is here. And default value is invoice.amount. So we have our form pre-filled because we're editing now, we're not creating. Okay, so quick point about why UUIDs versus auto incrementing. Saying, hey, UUIDs make the URL longer, however, UUIDs eliminate the risk of ID collision, they're more unique, and they reduce the risk of enumeration attacks, which are more ideal for large databases. However, if you prefer cleaner URLs, you might prefer using the auto increment keys. Pass the ID to a server action. Do we already have a server action, or we have to create one? We have to create one. Okay, so first things first is that we cannot do this. Update invoice ID. Well, first of all, we don't even have this function. So let me create a skeleton for that. Export async function update invoice. Okay. And let's import that. Okay. So we can't do this. doesn't say why, but we can't do this because let's see here. It doesn't explain why. It doesn't say why we can't do this. So I'll let that be exercised to the viewer. But instead, they want us to create a new action based on this one called update invoice with ID. And basically, we're just binding. We're taking the original update invoice and we're going to bind the ID to it. And then we will pass this function to our action. And I spelled invoice wrong here. Invoice. Okay. There's a TypeScript error here because we did not type this out yet. And then if we go to our actual function, we can use the create a schema for it. Again, where you omit the date, ID and date. We are going to, now that we binded it, we can get the ID from it first, and then we will get the form data. And that'll fix the TypeScript error here. And now let's just do the same thing here. Validate the data. Get the amount in cents. Here's an SQL query that will update invoices. Set customer ID to the new one. Set the amount to the new one. Set the status to the new one. Where the ID is equal to the ID. We validate path and take us back to the invoices page. Save. Okay, let's test it out real quick. We're on Stephen Tay. 448. Let's make it 450. Edit invoice. There we go. Stephen Tay. 450. Delete invoice. So usually deleting is the most easiest of the CRUDs because we just need the ID most of the time. So we are going to go to our UI invoices buttons. Then we'll go to our delete invoice. Do you want to go here? Here we go. Delete invoice. It's just a button. And we are going to, instead of a React fragment, we will make this a form. We'll make an action with delete invoice with ID, which will be similar to our update. We're going to bind the delete invoice function dot bind null ID. Okay, but this does not exist. So let's go ahead and make that real quick. To our actions, export async function delete invoice ID string. Okay, save. All we need is the ID. We don't need the form data. And our action is very simple. And because we are not going to a separate page, we don't have to do redirect because we're already on the invoice dashboard / invoices page. SQL is delete from invoices where ID is ID. Cool. And that's it with server actions. Let's just see it in action. So remember this Lee Robinson one we made in the beginning, $200. Let's go ahead and delete it. There we go, it's gone. We got full CRUD functionality now. We get invoices, we can create invoices, we can edit invoices, and we can delete invoices. And we didn't have to make any API endpoints. So you see how much more like streamlined this is to use server actions. And again, you can still use API endpoints, which we are not doing in this tutorial, I believe. But you have the flexibility to choose, and options are always nice. So we're done with chapter 12. Sorry, chapter 12. Chapter 13. Sorry about that. Handling errors. So we made a lot of server actions last video, but we didn't handle any errors. So let's see how we can do this. So we will first start with the classic way of adding try catches to our server actions. Okay, they want us to try it ourselves before seeing solution. I'll do the first one, and then I will look at the answers for the rest. So the question is, where do we want to put our try catch? So I know that parse throws an error, so I'm going to put it around everything. So try all of this. And then catch error console.log error. So I know that redirect has issues inside the catch block, but let's see what Next.js tools tell us anyways. So reveal the solution. They put the try. Okay, they put the try around the SQL. I don't entirely agree, but let's do what they have. So instead of console.log error, they're going to return a message. Return message. Database error, failed to create invoice. Okay, and again, they left us outside the revalidate path and redirect outside of the try catch. Cool. Let's go to invoices. I mean update. And I'm gonna assume they also just put a try in front of SQL. So right here, try. Catch error. Message. Database error, failed to update invoice. And again, try catch error. Can we guess the error messages? Could it possibly be failed to delete invoice? Yes, sir. Okay. There you go. So that's our try catch, which it will protect us from the SQL failing. So it's better than nothing. And so here they want us to manually throw an error. So throw new error. Failed to delete invoice. Invoice. Cool. And let's try it out. Here we go. Let's delete Stephen Tay. Delete. And we have a runtime error. Throw new error, failed to delete invoice. Because, we manually triggered that. So when you delete an invoice, you just see an error on localhost. Seeing these errors are helpful when developing, as you can catch any potential problems early. However, you also want to show errors to the user to avoid abrupt failure and allow your application to keep running. Okay, so this is where another special file comes in, error.tsx. Just like the page.tsx, just like the loading.tsx, just like the layout.tsx. Error.tsx is a special file to define a UI boundary for a route segment. It serves as a catch-all for unexpected errors and allows you to display a fallback UI to your users. So inside our dashboard invoices folder, so again, we have a lot of nested folders here. Let me see if I can make it a little minimized. We'll create a new file in the invoices file folder, right next to the page, right next to the layout, called error.tsx. And error.tsx has to be a use client component, always. And then here's a standard layout. We can use effect because it's a client component. So export default function error, we can error and a reset. Use effect, it'll just log the error, and it's watching the error. Main tag, h1, something went wrong, button. It's just a simple button, try again. It'll attempt to recover by re-rendering the invoices route. Let's test it out. So we should see this error. Because now we have a error boundary in our invoices folder. Any errors that happen in our invoices folder should be caught by this error.tsx file, and we should render this page. So Stephen Tay, delete. Oh, something went wrong. So we still get this. We still get the runtime error for our development. But now we have this nice, like the user sees something that's a little bit more friendlier to work with than nothing. And our app is still running perfectly fine. Try again, we'll bring back to invoices. Looks like it's some kind of reset method that gets passed in automatically. Does it talk about that? Right here. This is the function to reset the error boundary. When executed, the function will try to re-render the route segment. This object is an instance of JavaScript's native error object. Okay, that's good. Okay, so we're logging the error, but we're not displaying it anywhere. But that because the client component, we should have seen the error here. Here we go. Error, failed to delete invoice. Okay, and let me refresh the page. Okay, so handling 404 errors with not found. So another way we can handle errors is using the not found function. And so, for example, if we visit this, I want to do, let's do this. Obviously, if I press edit here, we will go to your edit page. But let's put it UID doesn't exist. So maybe like, I don't know, 31. Okay, so now we do an error, right? Because we could not, let's go to the ID edit page. We could not fetch invoice by ID because the ID doesn't exist. And let's just see what the error is here. Right, we don't have an invoice.id because the invoice is undefined. Okay, you'll immediately see an error.css kick in because the child wrote of invoices. Right, so we automatically get this page again because we made a UI boundary for our invoices endpoint. However, if we want to be more specific, you can show a 404 error. You can confirm the resource hasn't been found by going to fetch invoices by ID function, d.ts, and logging your return invoice. Sure, we can do that for fun. So right here, we will just log invoice. And let's see where a server shows. Clear, save. Here, you have an empty array. Okay, so now that you know your invoice doesn't exist in your database, let's use not found to handle it. Okay, and we are going to import the function. Let's remove this log. Let's close these buttons, close these actions, close this error. So right here, we are importing a nice handy utility function by Next.js called not found. And then we're just saying here, if there is no invoice, I want you to throw a not found. I don't want you to render anything. So let's see that in action. There we go. So not found throws us automatically here. And okay, cool. So it'll throw an error if the specific invoice is not found to show an error UI. So now let's make it more nicer for user. Sure, something went wrong, but what went wrong? Because we know exactly what went wrong and invoice was not found, let's try to make it more visible for the user. So another special page in Next.js is called a not found page. So we're making this directly in the edit page, and we're calling it, we have to call it not-found.tsx. And we're going to go ahead and create this component, just a main tag with a frowny face icon, H2404 not found, paragraph, could not find the request invoice, and just a link tag saying, hey, go back to the invoices dashboard. So we're only going to get this not found page here when we throw the not found function for no invoices. Any other error is going to go to that something went wrong page. So let's go ahead and show this again. Let's edit Stephen Tay, but we know he exists. So let's go to a random UUID 31 404. Not found, could not find the requested invoice. So a much better message for the user. And we have it scoped to the edit endpoint. So you can have these anywhere. If you have another resource called, like, I don't know, blog post, you could throw a not found there, and you can say like 404 blog post not found. And it could be a separate fallback UI than this one. Okay. So so refresh the page, we'll see this UI. We got this already. Quiz time. Which file in Next.js serves as a catch-all for unexpected errors? The error.tsx. Cool. Reading chapter 13 completed. Let's move on. Chapter 14, improve accessibility. Okay, so accessibility is pretty cool to have in an introductory tutorial because you don't get that in many often tutorials. And if you really want to be a front-end developer, like a pure front-end developer, you need to know like best practices for accessibility. So let's go to our thing. I'm gonna skip a lot of this text. I feel like I've been rambling on it too much, so I'll just try to cover like the main points. What is accessibility? Accessibility refers to designing and implementing web applications that everyone can use, including those with disabilities, right? Keyword accessibility, access. It's a vast topic that covers many areas such as keyboard navigation, semantic HTML, don't just throw divs everywhere, images, colors, videos, etc. Okay, so there's more resources here. We won't go in depth, but it's better than a nice big picture is pretty important. So it looks like we're going to use the ESLint accessibility plugin in Next.js, which is already by default included with Next.js. Cool. So for example, the plugin warns us if we have images without alt tag to use the area attributes and role attributes incorrectly and more. So let's see how it works. So let's add a script to our package.json. Let me close some files. Script to our package.json called lint, and it'll be Next.lint. Okay, and looks like my pretty are automatically formatted up here. And let's see here. So let's just go ahead and run that command. So I'm gonna shut down my dev server. I don't have to, but I'm going to. And we'll run npm run lint. So no ESLint warnings or errors. Okay, cool. But let's force one. Let's go to UI invoices table. UI invoices table. And we have an alt tag right here. Let's go ahead and just comment that out. Save. And we will run the script again. Warning, in app UI invoice table 88, line 88, column 23. Warning, image elements must have an alt prop, either with meaningful text or an empty string for decorative images. Okay, and then if we try to deploy this application to Vercel, we would get this warning in our build logs, so we can run it locally to make sure we catch any of these lint errors before we deploy. So let's go ahead and put this back, save. Including form accessibility, semantic HTML, make sure we use inputs and options instead of divs. Labeling, let's make sure we use the label element and the HTML4 element to make sure each form has a descriptive label. Focus outline, so make sure when you're using the keyboard to navigate between elements, you have some kind of indicator, like an outline for each element when you are on it. Form validation. So let's go, let me pull up the dev server again. Okay, we're back here. And it's saying, let's go to our create invoices. Let's press create invoice with an empty field, empty fields. What happens? Something went wrong, right? We shouldn't even be able to do that. Or try our best to prevent that from happening. You get an error because we're sending empty form values to our server action. Okay, so client-side validation. Not the strongest, but it still helps things like submitting an empty form from the front end client. So let's go to our invoices create form. And let's go to our input for amount. This is too much text here. Let's go down here. And right here, we will stick in a built-in HTML validation called required. Save. So now if I go ahead and submit this form, at least it won't let us because our amount has a required attribute on it. This can be bypassed, but at least it's a small safety net. Okay, and now this is generally okay because most ATs support browser validation. What is ATs? ATs. Let's learn together. Let's go to ChatGPT. In this sentence from Next.js's tutorial, what does AT mean? AT typically stands for assistive technology. Assistive technologies are software or tools designed to assist people with disabilities in using computers and access to digital content. Okay, cool. So like screen readers and stuff. So what did it say again? I lost everything. Yeah. This approach is generally okay because some assistive technologies support browser validation. Okay, an alternative to client-side validation is server-side validation. Let's see how we can implement that in the next section. Okay. For now, delete the required attribute fields if you added them. Okay, let's delete it. Okay, server-side validation. By validating forms on server, you can ensure your data is in the expected format before sending it to your database. Reduce the risk of malicious user bypassing client-side validation and have one source of truth. Okay, so basically it's saying instead of just doing it on the client, let's just do our validation on the server, because at the end of the day, this data is going to the server. So let's make sure the data is there in the server. That way we don't have to worry about trying to validate on the client and the server. Because you can send the API request to the server directly without the form. So you can send it directly without the form, and you can send it with the form. But in both cases, you're going directly to the server. So let's just validate the data on the server. Right, so in our create form, looks like we have to make this a client component because we're going to use a hook. Okay, and this hook is not Next.js specific. It is called use form state from React DOM. Save. Okay, and so inside your form component, use form state hook takes two arguments, action and initial state, and returns two values, state and dispatch, similar to the use reducer function hook. So let's set this up. So const use form state takes in an action. So we already know what action we're doing, create invoice, and initial state. Initial state. We're going to create the initial state in a minute. And then we will get out from that the state and a dispatch. So let's create that initial state function. Const initial state. We message null. So before we even send anything to data, what does our state look like? We're having a blank message, blank errors. And instead of passing the create invoice action to the form, we are passing the dispatch. So we can work with the use form state hook. And we have to edit our, you see something? We have to edit our server action to work with this hook. And we're going to do a couple things. First, we're going to add error messages to our schema. So we're going to add a invalid type error. Please select a customer. We are going to add an .gt of 0, so make sure it's a positive amount. Message, please enter an amount greater than $0. And finally, we will get status, comma, invalid type error, please select an invoice status. I need to do comma here and print here. Okay. So now if we throw an error for these fields, we'll get the specific message that we created to make it a little bit more user friendly. Okay. And now we need to temporarily, looks like we have to create a placeholder type for our state. So let's do that. Let's just do it right here. Export. I'm just going to copy it. I'll leave this comment in here too because it seems important. So this is temporarily until add types React DOM is updated. So export type state is that errors object before. It could have an error for customer ID. It could have an error for amount. It could have errors for status. And it could have a message. Remember, this is very similar. This is the structure of our initial state message error. Okay, and we're just going to pass the previous state to be state. Okay, fixes the TypeScript here, fixes the TypeScript here. Okay, and we're not going to use the previous state at all. We just need to have this here for the use form state hook to work. Okay, and instead of parse, we are now going to use save parse. And the difference between parse and save parse is that save parse will let us manually throw an error, instead of parse will automatically throw an error. So we have to now do if validated fields dot success is false, and return errors validated fields dot error dot flatten. This is all Zod stuff. And message, just copy it. Missing fields, failed to create invoice. So now this is separate from our other error, which is a database error. It's a little bit more direct error messages. And then we can pull out the data again from validated fields.data. And what do we need? We need the customer ID, we need the amount, and we need the status. Cool. So again, we're doing this with save parse to manually throw the error, or return an error in this case. Okay, and everything else should be the same. Yeah. Let's go back to our create form. Looks like we're going to go to our choose a customer label, and we're going to go to our select element, and we're going to throw in this area described by, which I'm not too familiar with, but it's going to be customer error. That's the label of this area described by. And then right below our select field, we're going to throw in this div, which has the ID of customer error, which connects this to this, and area live polite, area atomic true, and then if the state, remember this is a state, and this is the initial state. So if the state has errors, and if it has specifically the customer ID error, then let's map the errors to a bunch of paragraphs that are colored red. And we'll do the same exact thing for, let's see, does it want us to? Sure, let's test it out. Oh, use the example above, add errors to your remaining fields. So let's go ahead and do that real quick. So right here, we'll call this amount error. Copy this div. We'll put this right here. Where do I want it? Below the relative. Okay. Oh, it's two relatives. I'm being picky about this because I want it to be exactly in the same spot. Okay, we'll just do one div above. Okay, so this is going to be described by amount error. Amount error, and this would be errors.amount. Okay, and then last but not least, we have the field set, which I guess would have to be put on both inputs by status error. Status error. And let's copy this div here. This will go right. Okay, not sure where exactly to put it, but let's put it right here. And this will be for status. Okay, that looks good. Let's test it out by pressing create. And we got some errors. Please select the customer. So let's select the customer, submit again. amount greater than 0, put negative 34. Still get the error. Paid, create. Cool. So we still have our validations working. And let's see here. Once you're ready, hit npm run lit. See if we're using these labels correctly. Let's go ahead. npm run lint. No lint errors. Let me quickly update my npm. Okay. Let's run lint again. No errors. npm run dev. Okay. If you would like to challenge yourself, take the knowledge you've learned in the chapter and add form validation to edit form.tsx. Shall we do that? Let's see here. Yeah, let's go for it. Let's go for it. I'm going to go ahead and open up my VS Code and let's just do it quickly. I'm going to split my actions file so I can just copy what I had before. I'm going to use the same state. I know I'm copying the exact same thing, but just for the sake of looking back as notes, let's just keep it like this. Oh, we can't. So yeah, I will put the state type at the top because I'm going to use it twice. Let's put it. Yeah, let's put it at the top. It's fine. Okay. So update invoice function, we will take the previous state, which is the state. Okay, and then we will do what? We will use safe parse. Safe parse. This will be validated fields. If the fields are not successful, let's go ahead and just throw same thing, and then we'll do const. We can copy this line too, actually. No problem. Okay. And everything else stay the same. So that's good. So we're done with the actions file. Go and close that. We will open up the create form. We will open up the edit form on the side. We should have an error. Yep, because we didn't. So let's do same thing here. Import use form state. We will create an initial state. And then we will do a pass in this update invoice with ID to our use form state. And then we'll pass the dispatch to our form action. And we looks like we are. Okay, so it looks like actually, I think this is what I have to do. I have to go to our update form action. And we have to switch these, I think, like that. There you go. Yeah, so the ID is going to go first, then the previous state. Because we're using the bind here. Yeah. I think that's pretty much it. Let's check it out real quick. Let's go to our invoices. Oh no, we have to do our errors. So I'm going to copy exact same errors here. So described by custom error here. Customer error, I mean. Amount described by. Then we have this error message right here. Save. Scroll down. Scroll down. Status error here. Status error here. And finally, our final error message, which will go right here. Save. 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 Close. Okay, let's test it out. I pretty much copied everything from the update. Sorry if that was a little bit too fast, but that was a bonus exercise. I didn't want to drown on it too much. So we can try it out. Let's go to edit this evil rabbit right here. Now let's remove the name. We can't, well, select the customer. We can't click. Okay, so let's go to, delete the amount and press edit invoice. And we can't because we get the error message now. So that works out great. So the main point here is that we still got to use the form action, even though we used the hook. We did not use the onSubmit, and from what I know, that is still better way to work with forms and follow the idea of progressive enhancement. Reveal the solution, which I think is fine. So this is basically what I did. Initial state, binding. Then we go to our function, ID first, yep. Save parse, success, destructure. Okay, chapter 14. Except chapter 15, adding authentication. Alrighty, chapter 15, adding authentication. We're going to use Next.auth, which is now called Auth.js. And speaking of Auth.js, I have a really in-depth tutorial on Auth.js coming out soon, so I hope you can get a chance to watch that. So yeah, let's go ahead. This tutorial is authentication, another cool thing to add. So what is authentication? Authentication is a key part of many web applications today. It's how a system checks if the user is who they say they are. And this is a very important point here. Authentication versus authorization. Authentication is making sure the user is who they say they are. You're proving this by giving your username and password. Authorization is the next step. Once a user's identity is confirmed, authorization decides what parts of the application they are allowed to use. So authentication checks who you are, and authorization determines what you can do or access in the application. Time for a quiz. Which of the following best describes the difference between authentication and authorization? Authentication determines what you can access? No. Authentication verifies your identity. Authorization determines what you can access. Right? Keywords like, are you authorized to do this? Create the login route. Let me collapse and close. And let's create a login route, which is going to locate an app. New folder. Login. And new file, page.tsx. Page.tsx. Quick point, let's go to our dashboard just to see what we're working with real quick. Okay. And let's implement our login page. It looks very simple. We have a logo and a form. Here's the logo and here's the form. Let's peek into the form real quick. We have a simple form component. H1, please continue to log in. We have an email field and we have a password field and a login button. Let's peek into the login button. It's literally a button that just says login with an arrow. Okay. And let's look at this page. So it's localhost 3000/login. There we go. A nice simple login page. Okay, we're going to use Next.auth, so let's go ahead and install Next.auth. Copy this and paste. Okay, in order to use Next.auth, we're going to need a secret key, and we are going to use this secret key. Oh, sorry, we're going to use this command to create a secret key. So that's our nice secret key. When you're in production, make sure to use a new one because not the one I'm using in the video. And that's going to go right here under auth secret. I'm going to go ahead and save. Yeah. And if you want, you can put it in parentheses. Sorry, in quotes to make it more, in a way, easier to read, in my opinion. Okay, let's boot up the dev server again. I don't think we need the terminal. And we added our auth secret, adding the pages option. So let's create a new file called, in our root, called auth.config.ts. Here we go. And we're importing the type next.auth.config. And we're exporting a constant called auth.config, and we're setting the pages of sign in slash. So we're telling the app and Next.auth where is our sign in page, because otherwise it'll use this built-in sign in page. And now we have. Okay, I'm gonna type this out and explain this instead of just copying and pasting this one. Satisfies next auth config. And we need callbacks and we need providers. So providers is why it's throwing an error. So let's go with that. So callbacks. Callbacks are what to do during the process of routes that are authenticated. During the sign out, sign in, sign up, when you're changing pages. So one of the callbacks, see TypeScript's helping us out here because we satisfy next.config. These are all the callbacks. We're using the authorized callback. And we're destructuring a couple of things here. The auth and the request, and we're destructuring the request even more to get the next URL. So everything that's going on, this authorized callback right now, is going to be controlling basically, hey, if you're logged in, you can be on the dashboard. If you're not logged in, I want you to go to the login page. So we're going to create a couple of booleans here. The first is logged in, and this is just going to be the double exclamation point is going to turn into a boolean. So if we have a user, then is logged in will be true. If we don't have a user on the auth object, then we will not. Then is logged in will be false. Next boolean we will use is on dashboard, and all it's saying is look at the next URL, look at the path name, and does it start with dashboard? So this will cover dashboard. This will cover dashboard / invoices. This will cover dashboard / whatever else we had. I don't remember. But it'll cover everything starting with everything on our dashboard. So our whole dashboard will not be accessible if we're not logged in. So this will be true or false. And then so now we have a couple of if statements. Is on dashboard. So if we're on the dashboard and we are logged in, return true. Okay? If you're on the dashboard pages and you're logged in, you're good to go. Otherwise, just return false. Okay? I'll write the comment here. Redirect unauthenticated users to login page. Else, so that means we're on any other page that's not a dashboard page. So if we are, else if we are logged in, then return response.redirect and redirect the user to the dashboard. Because if they're logged in, why are they on the login page? Let's put them to the dashboard. If they're not logged in and they're not on the dashboard, they can stay wherever they are. So if they're on the logged in page and they're not logged in, they should be able to stay there. Okay, so that covers that. We protect our dashboard pages, and we only let them go in if they're on the dashboard page and if they're logged in. So we have some nested if statements here, but I think personally this is pretty clean. And we're keeping it all in one file. Okay, so now we're going to use Next.js is a middleware API, which is also really cool. So we just create a new file in our root called middleware.ts. It has to be called middleware.ts. And I will go and type out most of this. So we'll import next.auth from next.auth. We will import our auth config, which is that file we just made. So this whole config file we're gonna import, and we'll export a default next.auth, pass in our auth config to next.auth, and we'll export the .auth property on it. Okay, so let's just read what they say here. Oh, and we need this matcher. And basically this matcher says run this middleware on these paths, which says does it explain? We can read that real quick. Let's see here. So yeah, basically saying here, we match all requests. I'm just gonna copy this. Okay. Match all request paths except for the one starting with API, next static files, images, and the favicon. So we don't want the middleware to run on the favicon and our static files or API routes. We just want it to run on the actual pages. So it's going to run on every other path. And then so here you're initializing Next.auth with the auth config object. That's this part right here. And exporting the auth property. You're also using the matcher option for middleware to specify that it should only run on specific routes. Okay, the advantage of employing middleware for this task is that the protected routes will not even start rendering until the middleware verifies the authentication. So this middleware will run before every page. So when it's changing pages, it's going to run the middleware first, and then based on our callback here, we will see if we can even go to that page. Okay, password hashing. Let's see here. So yes, it's good to never store plain text passwords, always hash passwords. So in our c.js file, which is in lib, maybe? Yeah. No. Where is our c.js file? Scripts. In our scripts c.js file, we have a function. We have a library called bcrypt, and basically we are just going to hash the user's password with bcrypt.hash. Let's see here. You were using it later this chapter? Okay, so we can pause on that. Let's create a new file called auth.ts on our root. And auth.ts works together with auth.config.ts, but it's two separate files. You can read more about that in next auth documentation. Okay, so here we have our next auth imported. We have our auth config, which is right next door, and then we are exporting const here next auth. We're going to spread the auth config, and we're going to extract the auth function, the sign in function, and the sign out function. And here's where we're going to add our providers. So if you recall, the providers was an empty array. Because we spread this first, now we can override the providers with actual providers. And we're doing this for reasons that I feel like are out of scope of the tutorial. So we're going to import credentials from nextauth/provider/credentials. Okay. So it's recommended to use OAuth providers instead of credentials providers, because I guess it's more safe. But I think it's more of a good learning experience to use credentials providers, and that's what they're using. So we're going to import z from Zod, and in the credentials provider we will have an async authorize function, which will take in credentials, and we can do parse credentials. So right now credentials is as type. Let's see here. Pretty much anything. So we need to use Zod to make sure the credentials are what we want them to be, which is an email, and Zod is a handy email validator, and a string password with a minimum length of 6. And right now, we're talking about the login or sign-in functionality right now. Safe parse credentials. Okay. It's going to throw an error for the moment because we're still working with TypeScript. And this is pretty much the reason why we have to create a separate file to work with a database. So import SQL from Vercel Postgres, import type user from our types at, and import bcrypt from bcrypt. This is for logging in. We have to check if our hash is okay. Then we're going to throw this function at the top. Get user. We're going to pass in our email, and we're going to return a user. Select star from users where email is email. If you remember our c.js, we actually inserted a user. we mapped over the users, which was a single user whose email is user@nextmail.com and password 123456. So we already have a user in the database. We just haven't used it yet. And so let's do this. So if parse credentials.success, let's pull out the email and password. Let's get the user using our get user email, and if there's no user, return null. And then outside we'll also return null. But we're not done yet. Then here we will do. So if we don't have a user, return null. Now if we have a user, let's check if the password is good. So passwords match is bcrypt.compare the password you gave us versus the user's actual password. If the passwords match, return user. So if this is true, then return the user. Otherwise, we will return null. We can even do this log here, invalid credentials. Okay. And now we have to update our login form, it looks like. Let's see here. So we're going to go to our actions. Actions. Lib actions. And we'll go to the bottom. Oh, let's delete this error right here. Okay. And let's actually minimize these. Okay. Let's import sign in from our auth file, and let's import auth error from next auth, which should be a class, I believe. Yes. So export async function authenticate, which will take in a previous date of string or undefined. So it looks like we're going to use the use form state hook later. Form data is equal to form data. And we have a function, like try catch. So await sign in. We have to pass in our provider. We're using credentials. And we have to pass in our form data. Okay, and then we'll catch the error. And let's just copy this. So if the error is an instance of auth error, we'll switch. That means it could be it has a type property on it. And if the type is credential sign in, we'll return invalid credentials. Otherwise, we will return something went wrong. If it's not an auth error, we'll just throw the error. Okay, and let's go to our login form. And just like I said, we're going to use the use form state hook. So we're going to have to go and make this a client component. We've seen most of this before with the invoice form, so I'm going to copy paste most of this. Okay, we also have a new hook here called use form status. So I'll slow down when that part comes. We're importing the use form state hook, which we've seen before, the use form status hook, which we haven't seen before, and the authenticate function we just made. Okay, we're going to go ahead and initiate the use form state. We'll pass in the authenticate action, and we'll make the initial state undefined this time instead of the object. And we're going to go ahead and pass the action of dispatch. Okay. And anything else we need to do? Oh, so right below the login button. So right here, add form errors here. Thank you for the comment. Right here. So we will have basically just a little message showing the error, if we have an error. And our error is going to be here. We're calling this, last time we called it status, I believe. We're calling it error message. What did we call it in the create form? We called it state. So we're just calling it error message. We're being more explicit. It's not an object this time. Okay, so use form status allows us to get access to a pending variable. And this pending variable is useful because we can show when a form is in the middle of submitting. So we have to use form status on a button that is inside of a form. So this login button is inside the form. The button just extracted out. Use form disabled is equal to pending. Okay, so now we have this function as pending. We should see something show when it's signing in. And then it wants us to jump out to the side nav and add that functionality to the sign out button. So where's our side nav? It's on dashboard, side nav, and right here. So we're gonna do everything in line this time. Action is equal to async, and we'll do use server, and we'll say await sign out, which comes from our auth. Quick reminder: our sign in and sign out functions are coming from this auth.ts file we made. Auth sign in sign out. Try it out. Okay, so let's try it out. Let's go to our login page. Let's first submit nothing. Login. Let's try user at nextmail.com, and let's put the wrong password in for it first. So 1, 2, 3, 4, 5, 6, 7. Invalid credentials. Now let's try 1, 2, 3, 4, 5, 6. And we are signed into our dashboard. Let's try our middleware. Let's go to login. If we shouldn't be able to go to login anymore. The middleware should redirect us to the dashboard page. Yep, see? And let's try signing out. And that works. And let's try to go to the dashboard page. It shouldn't let us. Dashboard. Yep, see? So we can log back in again. User at nextmail.com. 1, 2, 3, 4, 5, 6. This is a very bare bones authentication that we just set up. But it's pretty useful information. And that's the end of chapter 15. We have reached the final chapter of the Next.js app router tutorial, adding metadata. Metadata is crucial for SEO, search engine optimization, and shareability. In this chapter, we'll discuss how you can add metadata to your Next.js application. What is metadata? In web development, metadata provides additional details about a web page. Why is metadata important? Metadata plays a significant role in enhancing a web page's SEO, making it more accessible and understandable for search engines and social media platforms. So types of metadata. There are various types of metadata, each serving a unique purpose. The title metadata, title, page title. So that's what we see up here on a tab. That's the title metadata. And ideally, if we go to different pages, right, we would want to see different titles. The description metadata, which provides a brief overview of the web page. This is in the head. We don't see it on the page. We just see it in the metadata. Keyword. I'll show you where that is in a second. Keyword metadata. So keywords. Open graph metadata. So this is like a way for us. You know how you can share a link to somebody on social media like LinkedIn or Facebook or Twitter? Sometimes when you post a link, there'll be like an image will automatically show up, like a preview of a website. That's what the Open Graphs stuff deals with. And then favicon metadata, right? So our favicon. So right now we have this default Next logo right here. So let me quickly show you in the head of our HTML document. See all this metadata? This is where it's coming from. See, we don't have a description here right now. But if we go to maybe a google.com, I'm hoping has one. Let's go to the head and let's see if we can find a description. Here maybe. Content, origin. Okay, let's try one more website. W3 schools. Head. Let's see here. All right, we have the keywords here. HTML, Python, CSS, SQL. Description. Well organized and easy to understand web building tutorials. Okay. Additional metadata. So Next.js has a metadata API that can be used to define your application metadata. There are two ways you can add metadata to your application. Config-based, so we can export a metadata object or a dynamic metadata function in a layout.js or page.js file, or file-based. So Next.js has arranged special files that have metadata purposes, like the favicon.ico, or if we create a file called robots.txt or sitemap.xml, or opengraphimage.jpg. So Next.js will look for these file names, and it'll work with that to help you with your metadata. You have the flexibility to use these files for static metadata, or you can generate them programmatically within your projects. With both these options, Next.js will automatically generate the relevant head elements for your pages. So in your public folder, you'll notice two images. Let's go to our public folder. We have favicon.ico and the opengraphimage.png. So this open graph, we didn't use it anywhere in our app, but ideally this image should be showing up if we share it on Facebook, for example. So let's move these images to the root of our app folder. Okay, so I'm going to select this, and we're going to move it to our app folder. Okay, so let's close the public. And nothing's going to really change with our website. And so after doing this, now that it's in our app folder, it will automatically identify and use these files for your favicon and OG image. You can verify this by checking the head element of your application dev tools. Yeah, let's check it out. Console, inspector, head. So let's see here. Yeah, here we go. The OG image is now here. These were not here before. And the favicon should be here too. Yeah, here we go. And we also have ones for Twitter. So that's nice. So now we share our website on Twitter. It'll show a nice preview of this nice preview of our app. So now, something that's you'll see more often when you start an Next.js project from scratch. Let's go to our app layout page. So the main layout right here. And we can export metadata. We can export an object called metadata on every layout or page. And it has a lot of properties, but these are the three that they want us to work with. The title, description, and metadata base. So it looks like that's our, we'll explain it. Let's see here. Next.js will automatically add a title and metadata to your application. But what if you want to add title for a specific page? Let's freeze on that. Let's look at metadata base here. Metadata base is a convenience option to set a base URL prefix for metadata fields that require a fully qualified URL. Allows URL-based metadata fields defined in the current route segment and below to use a relative path instead of an otherwise required absolute URL. The field's relative path will be composed with metadata base to form a qualified URL. If not configured, metadata space is automatically populated with default value. So the output is okay. So it makes it easier to have more dynamic routes. So we can easily generate these three paths by using the base URL. Cool. Okay. So now remember this title. Remember what the title for the metadata was. The title was what shows in the tab, right? So now if you look at our tab, we have ACME dashboard. That's what we have here. But now we have ACME dashboard on every page. Or we should. I'm going to reboot my dev server. Yeah, so now we have ACME dashboard on every page because we're in the main layout. So it's the only part where we have metadata. So now it's going to apply to everything, which is better than nothing. So now it's saying, what if we want to have a custom title for a specific page? So let's go to our app dashboard invoices page. And let's bring in metadata here. So let's import metadata from Next. And we'll export the function metadata, and we'll just change the title, invoices ACME.dashboard. So because our layout still has this description and metadata base, this is going to apply to every page unless we override it. So here we're just overriding the title. So we have ACME dashboard on our dashboard. So if we go to invoices, we have invoices ACME dashboard. Customers still has ACME dashboard, home still has ACME dashboard, but invoices has invoices ACME dashboard. So now we can provide more scoped metadata to our functions, to our pages, to our website. So this works, but we're repeating the title of the application every page. So now, so let's make it a little easier for ourselves. Let's go back to our layout, and we can use something called a template. So a template, instead of using a string, we can turn the title into an object. And we can use template %s ACME dashboard. And the default will be ACME dashboard. So in other words, the title will be ACME dashboard by default, but if you want to use the template, you can just put whatever you want and replace this placeholder %s. So if we go back to our invoices, we can just type in invoices. So we can bring it back here, and we will see that we have everything should be back to where it was. Let's see. Invoices. Still have invoices up here because we're using the template. Okay, and now if you learn about metadata, practice by adding titles to the other pages. Sure, why not? Let's go to our login page. Let's copy from the create real quick. I'm going to copy these two lines. Import metadata from Next and export const metadata. So let's do it real quick for our login page. It's right here. We're just going to type in login. Save. Done. Dashboard page. So that's going to be, where's our dashboard page? We don't have a dashboard page, but we have a dashboard layout. So we'll just do it there. Dashboard. Dashboard customers. It's right here. Customers. Dashboard invoices create. Invoices create page. I'm going to call it create invoice. Create invoice. I'm going to copy this. And I assume the edit page. Yes. Edit page right here. And actually, because we're in the dynamic route ID, we could actually make this dynamic, like saying title, edit, ID number, invoice. But that's a little bit out of scope of this tutorial. So you can look into that. Look up dynamic metadata. Okay, and let's test it out. So we're on the I think I'm having some issues with the caching, so I'm going to go ahead and remove the .next. Ignore what I'm doing right now real quick. Okay, let's reboot everything. I'm actually going to go into our data file, and that delay that we had for, let's reduce it to 2 seconds. Okay. Okay, so dashboard, ACME dashboard. This should not be invoices. I'm not sure why. Let's go back to our invoices. Oh, it's because of our template. I see. So where is, I made a mistake here in this layout. This layout should not have this. So where is our dashboard page? Oh, it's an overview. Okay, okay. Okay, so let's go back to scratch. Okay, dashboard, ACME dashboard, invoices, ACME dashboard, customers, ACME dashboard, invoices, create invoice, ACME dashboard. We should have Edit invoice. Let's sign out. Log in ACME dashboard. Let's sign back in one more time. User at nextmail.com. I think that's the username. Cool. And that's the end of our dashboard. A really nice mobile, like prepared, responsive dashboard tutorial. And yeah, we've completed chapter 6. Next steps, let's just take a peek at that. So yeah, all the documentation on everything. There's more templates. There's a YouTube channel, the repository, more docs, product walkthrough. Share your Next.js app with @Next.js on Twitter, or I guess X now. And yeah, you completed the course. Congrats. I hope you learned something, and thank you for watching. Have a good day.